I'm often asked what makes the difference between a good React developer and a great React developer. And while there are obviously many differences that could be highlighted here, from a skills standpoint, I can't think of any faster way to go from good to great than by learning and mastering some of the tools that belong to what's referred to as the React ecosystem. The React ecosystem consists of a number of very helpful tools such as Redux, Thunk, Reselect, and many others that greatly simplify the task of creating large, performant React applications. And these are exactly the tools that this course will help you learn and master. I've been working with most of these tools on a daily basis for the past few years, and have loved every minute of it, and now I'm eager to pass on my knowledge to other developers. To get the most out of this course, there are a few things that would be helpful for you to know. First of all, it would be very helpful to have a basic knowledge of React. If you haven't already worked with React a little, I'd recommend you take a look at one of the React Basics courses in the library first, and then come back to this one, since we won't be covering any of the very basics of React in this course. It would also be helpful for you to have some experience with basic command line operations. All we'll be using for this course is basic commands like cd to change directories and ls to see the contents of a directory, as well as a few commands specific to Node.js. Keep in mind also that if you're on Windows, the commands might be a little different. I've left you a link to an article showing many of the basic Linux commands and their Windows equivalents. I highly recommend that you follow along with me as I write code, but I've also included the start and finish states for all the code that I write in this course in the exercise files for your reference. So basically, this course is intended for React developers who want to improve their development skills and the quality of their applications by learning to use a number of pre-existing tools in the React ecosystem. If you fit that description, then this course is definitely for you. We're going to start off here by installing the major tools necessary for this course, and that's Node.js and NPM. These will be really important for running our code and installing a few libraries we'll be using to make our programming easier. So if you don't already have these things installed, you can download the installer from Node.js's website, nodejs.org. All you have to do is pick a version to download, and then once it's downloaded fully, you just click on the installer, and it should take you through the steps required for installation. And if you're using Windows or a Unix distribution, these steps might be a little different, but Node.js's website has instructions for all of these as well. Once you've run the installer, you'll want to make sure that you have the most recent version of NPM installed. We'll be using a few libraries in this course, and NPM is a package manager for Node.js that allows us to easily install them. If you've ever done React development before, you've definitely used NPM. So to install the most recent version of NPM, just open your terminal and type npm install-g npm, and you might need to add sudo before this. And once you've done that, you can just type npm-v, and it should show a version that's at least as high as mine. Don't worry too much if your version is higher than mine, since everything should still run correctly in that case. And that should be all we really need to do right now. We now have Node.js and NPM installed. If you decide to use the exercise files that I've included to follow along with the course, there are a few things you should know first. The first is that the exercise files are organized by video. So for example, the code for video 7 in section 2 will be in a directory called 02_07, and this will contain both the start and end state of the code in that video. Now, assuming you want to run the code for that video, there's a few steps you'll have to follow. The first thing you'll have to do is open up a terminal inside the directory you want to run. So if we want to run the end state of 0207, we would change into that directory by typing cd 0207/end, and then once we're in that directory, we need to run npm install and hit enter, and that'll run for a few seconds, but once it finishes, all you have to do is run npm run dev, and the application should run successfully. Another thing to note is that if you pick up the course sometime in the middle during section 4 or later, there's a server that you'll have to run locally in order for the code to work correctly. This code is available for download alongside the exercise files, and in order to actually run this code, you'll need to run npm install in that directory, just like we did with our exercise files. And once we've done that, you simply need to run npm run start and hit enter, and the server should start up correctly. So that should be all you need to know to run the exercise files for this course. As I mentioned before, this course is aimed at React developers who have spent most of their time developing with vanilla React and are now looking for a way to more effectively manage the many different concerns present in a full-scale React application. Now, I firmly believe that this is an important step toward achieving greatness and, well, sanity as a React developer when working on large, complex React applications. So, my hope for this course is to give you solid experience with some of the most important tools in the React ecosystem. This course aims to help you make sense of the numerous and incredibly useful tools available to the modern React developer, learn how to use them correctly, and incorporate them into your React development environment. To do this, we're going to start off by creating a basic React application from scratch, and then use this application as a jumping-off point to learn about the many different tools that are available to us, including Redux, Thunk, Reselect, and styled components. We'll learn the basics of each of these technologies, such as how it works and why it's useful, and I'll walk you through the process of adding and integrating each one into your React project. And last but not least, because I'm a big believer in the importance of tests in any codebase, we'll see how to test all the technologies that we cover in this course. So by the end of this course, you'll have a fully functional React project that you can use as a reference for all future React projects that you undertake. You'll also have the understanding required to use each of these tools effectively to write beautiful, maintainable, and performant React applications, and skills that will help you excel in a corporate environment where such tools are used regularly. Well, I'm really excited to get started on this with you, so now that we have our basic plan of attack, let's jump right in. Before we get started learning all about the tools in the React ecosystem, it'll be helpful for us to take a good hard look at why we might want to make use of these tools in the first place. After all, these tools do have a bit of a learning curve, and to some developers, it might seem like they make the development flow, well, a bit more cumbersome than usual. So, as I mentioned at the beginning of this course, vanilla React, and when I say vanilla React again, I'm just referring to basic React without any of the additional tools that we're going to cover in this course, vanilla React was designed as an effective way to create modular, performant user interfaces. And as I mentioned before, if we're talking about the model view controller pattern, React's main concern falls squarely into the view portion. That is, it provides a straightforward and powerful way to take some data and display it in the user's browser, as well as efficiently update what the user sees whenever the data changes. However, when it comes to how we load, store, and manipulate that data that we're displaying, React doesn't really provide us with much guidance. And this is actually somewhat on purpose. The idea behind this lack of opinion is that it allows React developers to make their own decisions with respect to the best way to load and manage data in their application, and tailor React to their exact use case. The problem with this, though, is that it requires a lot of thought and experimentation to get it right, and in practice, developers rarely put that much thought into making these decisions. The end result is that all this logic ends up getting crammed straight into the components themselves. This means that what we usually end up with in a vanilla React application are these huge, tangled components that contain all the logic for loading and managing their own data, and this can make your React projects very hard to expand and maintain. So if you've already put a lot of thought into organizing the code in your React project, and you've found something that works for you and your team, then you probably don't need all the tools we'll talk about in this course. However, if any of what I've mentioned so far in this video sounds familiar, and I've been at many companies where this is the case, so you're not alone, you'll probably benefit a lot from learning about the React ecosystem tools and incorporating them into your codebase. So then, as you may have gathered so far, the name of the game when trying to organize a React application is separation of concerns. In other words, if we can find a way to effectively identify and organize the many different types of concerns in an application, this goes a long way toward making our codebase more maintainable. This thinking, of course, is the basis behind patterns such as MVC, which I've mentioned already. And fortunately for us, a lot of thought has already been put into identifying and separating the concerns in React applications, and this has led to many of the ecosystem tools we'll be covering in this course. In fact, for most of the tools we'll look at, the underlying purpose for their existence will be this separation of concerns. So now that we know the basic benefits of using React ecosystem tools in our codebase, namely that they help us effectively separate our concerns, we'll see exactly how to do this in later videos, let's briefly go through each of the ecosystem pieces that we'll be covering later in the course. Keep in mind that the goal here is just to get a 10,000-foot view of each piece and how it fits into our codebase. We'll go into much more detail about each individual piece later on. The first tool we'll be learning about and incorporating into our codebase is called Redux. This is without a doubt the most popular add-on in the React ecosystem. Its main purpose is to help us manage the state of our React applications in an effective and relatively bug-free way. And to do this, it uses what's called the Flux architecture, a very fancy name for a pretty simple concept which we'll go into more depth on later in the course. The next tool is called Redux Thunk, or just Thunk by most programmers. What Thunk allows us to do is separate out the so-called side effects of our application. And side effects are permanent changes such as modifying user data on a server or upvoting an article, for example. And the idea is that this allows us to avoid putting this logic directly into our components. Again, separation of concerns applies here. Our components are meant to display our data, and that's it. They shouldn't be worrying about making network requests, and Thunk gives us a place to put this logic. Next up are selectors, and the specific library we'll be using for this is called Reselect. While Redux takes care of managing and modifying the state of the application for us, the purpose of selectors is to abstract away the details of how our data is stored in the state. This will make more sense when we go in depth with selectors later on in the course. And after that, we have what are called styled components. Styled components give us a nice way of, well, styling our components. That is, they give us a nicer way of managing the appearance of our components than using separate CSS files, particularly when the appearance of a component depends on the state in some way. Again, you'll get a much closer look at how this works later on in the course. To start off this course, what we're going to do is build a React project from scratch. That is, without the help of Create React App or other boilerplate generators. This is a good experience for React developers to go through at least once, since it gives a lot of insight into what goes on behind the scenes in a React app. And these are things that most developers don't ever think about. So, since this is not an introductory React course, I'm going to assume that you're already familiar with Create React App and might want to go a little deeper into the inner workings of a React project. Once we've built this rudimentary React application from scratch, we'll use it throughout the rest of the course to demonstrate how to incorporate each of the ecosystem tools and concepts one by one. So the first thing you might be wondering is, what do we actually need in order to create a React app from scratch without using a boilerplate generator? Well, the main things we need, each of which we'll cover in coming videos, are 1. An index.html file. This is what will be sent to the client and what React will render our app into. 2. We need support for ES6, since obviously we'd rather write our code using modern JavaScript syntax. 3. We need webpack. This will take care of the actual building our app, as well as allow us to use things like CSS modules to style our app. And we'll also use it to serve our app during development. The fourth thing we need is a root component. This is the base of our component tree. You can think of it as the container that holds the rest of our application components. And finally, the last thing we need is something called React Hot Loader, which will allow us to see the changes that we make to our app immediately in development without having to refresh our app every time. And that's really all we need. We'll see how to do each of these steps in the following videos. The first thing we have to do is create and set up the directory that will hold our React project. First, you've got to create a directory and call it React Ecosystems or something like that, like I've done here. And once you've done that, open up a terminal inside that directory and run npm init-y to initialize a new npm package. And that'll create this package.json file here for us. And if you want to initialize this as a new Git repo as well, now's a good time to run git init. And once we've done that, let's create two directories inside of our root directory. We're going to call the first one public. This will hold all the publicly accessible resources for our app, just like in a regular static website. And we're going to call the second one source, src. This will hold our actual React code. The next thing that we're going to do is create a file called Index.html inside the public directory that we just created. Index.html. This Index.html file will be what gets sent to the client when they send a request to our site. So what we need to put inside this file is a bit of very, very basic HTML that'll look like this. We're going to start off with the doc type tag at the top, and then the HTML tags. And inside here, we're going to have the header. And it's just going to have a few helpful things inside. So we'll say meta charset equals UTF-8. Meta name equals viewport. Content equals width equals device width. Comma initial scale equals 1. Shrink to fit equals no. Just some very basic stuff that you'll see in most HTML. And finally, the title tag. We'll just say React Ecosystems. That'll be what gets displayed at the top of the tab, of course. And that's it for the head. Now we move on to the body. And we're going to define a div here that's very important. It needs to have the ID root. And this is the div that React will eventually render our app into. We'll see how to do that really soon. And then we usually include a noScript tag, just in case the user has JavaScript disabled in their browser. We say something like, please enable JavaScript to view this site. And last but not least, we need a script tag down here to load our React code. We're going to say script source equals, and then /dist/bundle.js. And note that this bundle here doesn't exist yet. We're going to get to that in just a minute. So make sure to save your file, and that's all we need for our index.html file. It's pretty boring, isn't it? All the magic is going to happen in our React code. But first, in order for our React code to actually work, we'll need to add support for ES6. So we're going to be writing our React code using ES6 syntax, and we're also going to need to add support for JSX, React's special HTML-like syntax for defining page layouts. And in order to do all this, we're going to start off by opening up a terminal inside our directory and running npm install --save dev at babel/core at babel/cli at babel/preset-env and at babel/preset react. And then we're going to hit enter. And that might take a little while to run, but once it does, the next thing we need to do is create a babel.rc file. This file will tell the Babel transpiler what presets and plugins to use to transpile our code. So let's create this babel.rc file in the root of our directory. Call it .babel.rc, don't forget the dot before it. And inside this file, we're going to define a JSON object, and this object will have a property presets. That will be an array of 2 strings. The first one's going to be babel preset-env, which handles the transformation of ES6 into CommonJS, and babel/preset-react, which knows how to deal with JSX properly. Babel will use both of these presets to transform our code into something the browser can run. Although, just as a side note, most modern browsers now support ES6 syntax, so this isn't as necessary as it once was. And that's it for now. Let's make sure to save this file, and we'll see later on how to actually use Babel to transpile our code using the presets we've defined here. Now that we've got support for ES6 and React syntax, although we still have to actually build and serve our project, we'll see how to do that in a coming video, we're going to create 3 files inside of our source folder. This is the first actual React code that we're going to write here. The first file that we're going to create is going to be called Index.js, and this will contain the code that inserts our React app into our index.html page. And then we're going to create 2 more files, one called app.js, and the other called app.css. And these 2 components will contain the code and the styling, respectively, for the root component of our application, which for now will be the only component in our application. So we're going to code this component first, open up app.js, and we're going to write the following code. We're going to say import React from React, and then import app.css, and then we're going to say const app equals, and we're going to make this a functional component here. And for now, our component is just going to be a simple div. We'll say class name equals app, so that we can add styling later on. And then we'll say h1 hello world. Nothing too complicated here right now. And finally, down at the bottom, we're going to say export default app. And now let's move over to our app.css file and just add in some very basic styling. It doesn't have to be anything too complicated. So we'll say .app, and we'll give it a margin 1 rem, font family, we'll say Arial, Helvetica, sans serif, and we're going to say color, we'll just say 222222. So that's our very basic React app so far. The only thing we have left to do is write the code that will actually render our app component that we just created into the index.html page that we defined. So here's how we do that. We're going to open up the index.js file that we created, and we're going to add this code into it. We'll say import React from React, import React DOM from React DOM, and finally we're going to say import app from app.js. And down here is where the actual rendering is going to take place. What we're going to say is React DOM.render, and we're going to render our app component into document.getElementById root. So we're going to be finding our root div that we defined in our index.html and rendering our app inside that. And last but not least, we have to actually install React and React DOM, these two packages we're using up here, so that we can use them in our app. So we'll say npm install React and React DOM. And that's all we need for now. The only thing we have left to do is set up Webpack to build and serve our project for us. So now that we've got a very simple React app set up, we need to set up Webpack to actually build our app. And what we're going to have Webpack do for us is take the code in our source directory and perform some operations on it, like converting the ES6 syntax and JSX to CommonJS, and then host our public directory so that we can view our app in a browser. Before we get started, let me just say that this is probably the least fun part of the whole process, especially if you're not familiar with Webpack. But bear with me, I'll explain everything that goes into our Webpack configuration and how it helps us. So the first thing we're going to do is install all of the packages that we'll need. So open up a terminal in our React Ecosystems directory here, and type npm install --savedev webpack, webpack CLI, webpack-dev-server, style loader, CSS loader, and finally Babel loader. And we're going to hit enter and run this, and that's going to take a little while. And before we go on, if you really want to make sure that you're getting the correct versions of the packages we just installed, especially Webpack, you can take a look at my versions in the package.json here. If you find that Webpack isn't quite behaving correctly for you, you can always specify the versions that I have here, and it should work exactly as it did for me. So the next thing we're going to do here is create our Webpack config file that will allow us to define what exactly we want Webpack to do with our source code. So we're going to create a file in our base directory here, and call it webpack.config.js. And then inside this file, we're going to write a bunch of code. So again, bear with me here. So first we're going to import a few things, path and Webpack. And note that since Webpack will be the thing that's actually transpiling our code from ES6 to CommonJS, the Webpack code itself is usually written in CommonJS. So that's going to look like const path equals require path, const Webpack equals require Webpack, And now we'll define our only export, which will be a JavaScript object that contains a bunch of configuration data for Webpack. So we'll say module.exports. Again, this is ES5 syntax here. And first we have to define our entry point for Webpack, which will be the Index.js file, since that's the one that imports all the others. /source/index.js. And we're going to specify the mode, and we'll have Webpack in development mode here. And now we have to specify the rules for exactly how we want Webpack to transform our code. Now, for those of you who aren't familiar with Webpack, Webpack does this by using what are called loaders, basically packages that Webpack uses to transform code in some way. So for example, the first rule we'll define will be to transform our ES6 code to regular JavaScript, and that'll look like this. We first have to define a module property, and that's going to be an object. And then inside here, we need a property that's called rules, and that's going to be an array. And the first rule here, as I said, will be to transform our ES6 code to regular JavaScript. And I'm not going to go into too much detail here again, but this will just have a property test, and it's a regular expression, so // dot parentheses, JS pipe, JSX, $/. Don't worry if that doesn't make sense to you, that's just matching all of the JS and JSX files. And we're going to say exclude /node_modules, because we don't want it to look inside our node modules folder. And then the loader we want to use is our Babel loader. And finally, we want to specify options, and that's going to be an object that says presets, Babel/env. And that's it for that rule. Next up, we're going to add the style loader and the CSS loader, and that allows us to do this thing where we import a CSS file at the top of our React components, like we did in app.js. We have to remember to add a comma up there. And then we're going to say test //.css, $, comma, and then we're going to say use style loader and CSS loader. And that's it for our rules. The next thing we'll add to this conversation is the resolve property, and make sure you add that outside of here. We're going to say resolve object extensions array, and that's going to be star.js and .jsx. And next up, we'll define our output files, which will look like this. Output object path.resolve __ dir name, and then dist /, and then public path is going to be /dist/. Make sure you get all these slashes right, by the way. And then we're going to say file name bundle.js. And next we're going to define some things for our development server, which again will allow us to view our React application in a browser. And that'll look like this. We'll say dev server object content base path.join __ dir name public / port 3000. Public path is going to be http // localhost 3000 /dist /, and then hot only is going to be true. This is something we'll talk about later. And one last thing, outside of dev server, we're going to say plugins, and that's going to be an array with one item. That's new webpack.hotModule replacement plugin, parentheses. And that's it. Now comes the exciting part. We can build and serve our React application by running npx webpack dev server -- mode development. And we can see that we got an error, and that is because this is not public. It is public path. So if we change that and save it and try and run it again, we see that it runs successfully. So now if we open up a browser and navigate to localhost 3000, we'll see the app that we just created. So we've got our React app up and running, which is great. But the problem, and granted it's not a big problem by any means, but still, the problem is that whenever we make a change to our code, for example, if we were to open up our app.js component and add some exclamation points, we have to physically refresh our browser in order to see the changes. And this is something we can fix pretty easily. Let's see how. So let's open up another terminal in our directory. I usually just leave webpack dev server running in the background. And we're going to run npm install save dev react hotloader and hit enter. And once that installs, we're going to open up app.js and add two little things. So first, at the top here, we're going to say import hot from React hotloader. And then at the bottom, instead of just exporting our bare app component that we defined, we're going to say export default hot parentheses module and then parentheses around app as well. And this will allow us to see any changes that we make to our app without hitting refresh in our browser. We'll see that in a second. First, in order to avoid having to remember and type out our webpack dev server command every time, let's define an npm script for it. To do that, just open up package.json, and right above our test script here, let's define a new script called dev, and then inside it we'll put our webpack dev server command. So we'll say npx webpack dev server -- mode development, comma, don't forget the comma there. And now all we have to do to run our app is type npm run dev and hit enter, and it'll build and serve our app for us. And note also that we can make changes to our app now, and we'll see them show up immediately without refreshing. And one more thing to note here is that while we're running our webpack server, there isn't a dist folder as we might expect. That's because what webpack dev server does is holds this dist folder in memory and serves it, and then deletes it when we stop it. If we want to actually build our React app so that we can see the files, what we can do is open up our package.json file and create another script in here called build. And then instead of running webpack dev server, we can simply run webpack. So npx webpack -- mode development. And don't forget a comma after that as well. So now we can run npm run build. And we see that our dist file with all of our transpiled code shows up right in here. But I'm going to delete that because we don't need that for now. So now that we've built ourselves a working React app from scratch, it's time to take a look at the application we're going to be building throughout the rest of the course. The app that we're going to be creating, as is pretty typical with many courses, is a basic to-do app that keeps track of things that we want to get done. So our app is going to allow us to create new to-do items. It's going to allow us to mark these to-dos as completed. And finally, it's going to allow us to remove these to-dos. Now, this might seem like kind of a simple app, but I've found that it's a very good way to demonstrate how to add different React ecosystem components to a React application. So, without further ado, let's get started with building the very basics of this app, and then later on, we'll use the ecosystem pieces to add more and more functionality to it. Okay, so the first component that we're going to create for our app is the to-do list component. And this is going to be pretty straightforward. The first thing we're going to do is inside our source directory, we're going to create another folder, and we're going to call it to-dos. And inside this folder, we're going to create a file called todoList.js. And from here, our to-do list component is going to be a pretty straightforward React component. We're just going to say import React from React, and then define our component. We'll say const todoList equals, and then its only prop for now is going to be the to-dos that it's supposed to display. And what it's going to do is inside a div with the class name listWrapper, it's going to simply take the to-dos that it gets as a prop and say todos.map, And for each to-do, it's going to display a todoListItem component. We'll create that in the next video. todoListItem. And the prop it's going to pass is the to-do that we're mapping. To-do equals to-do. And finally, at the bottom of this file, we're going to say export default, to-do list. And up at the top, we're going to say import todoListItem from /todoListItem. And this file doesn't exist yet, but we're going to create it really soon. And that's our component, plain and simple. The only other thing we're going to do is create a CSS file for our to-do list. And since this isn't a web design course, I'm not going to do any styling here. If you want to style these components, feel free to do so, or just use the styling found in the exercise files. So now that we've implemented our to-do list component, the next thing we're going to do is implement this todoListItem component to display the individual to-dos. And in order to do that, we're going to go through pretty much the same flow that we followed to create our to-do list. We're going to create a new file inside this to-dos directory that we created. We'll call it todoListItem.js, and we'll create todoListItem.css as well. Although we're not going to do the actual styling in this video, you can look at the exercise files if you want to take the styling out of there. And for this component, we're going to say import React from React, just like we do with all our React components. And we're going to define our actual todoListItem component. We'll say const todoListItem equals, and then its only prop for now is going to be a single to-do that it displays. And then for the JSX for this component, we're going to have a div with the class name todoItem container. And inside here, we're simply going to display the to-do's text property. So we'll say todo.text. And then we're going to display two buttons, one for marking a to-do as completed, and one for removing a to-do from our list completely. So we'll say button, mark as completed, and button, remove. And we're going to put these buttons inside their own div, just for styling purposes later on. And we'll give this div the class name buttonsContainer. And we'll give this button the class name completedButton and removeButton. So for now, that's it for the internals of this component. It's nothing too exciting yet, and that's where our ecosystem tools will come in. So at the bottom, let's say export default, todoListItem, and that's it for now. Okay, so far we have our to-do list and our todoListItem components. The next and final component that we're going to add is the newTodoForm component. And this is a component that our users will be able to use to create new to-dos. So it'll have a text input as well as a button. So first, let's create our new files. We'll say newTodoForm.js and newTodoForm.css. And it's going to be very similar to our other components, where we say import React from React. And then we're going to define our component, const newTodoForm equals, and for the time being, this component isn't going to take any props, although it'll definitely get some later on in the course. And now for this newTodoForm component, we're going to have a div with the class name newTodoForm, and it's going to have an input. We'll say type equals text, and we'll add more to this later on, but for now this is all we need. And we're going to have a button with the text create to do. And we're going to want to add class names to these as well. Class name equals new to do input, and class name equals new to do button. And we're going to export this component, just like our other ones. Export default, newTodoForm, And for this component, what we're going to want to do is add state to keep track of the current value that's contained in our text input here. So in order to do that, we're going to import useState from React. If you're not familiar with this, this is a React hook. But don't worry about the details right now if you haven't seen it before. So in order to keep track of the value in our input box, we're just going to say const brackets input value set input value equals useState and then an empty string. And the way we're going to use this is with our input element here, we're going to set its value equal to input value. And for its onChange function, we're going to say that we should set the input value to whatever the new value of the text input is. So e.target.value. And last but not least, we're going to want to have a placeholder there. So we'll say placeholder equals type your new to-do here. And that should be all we need for our component right now. The last thing we're going to do is just make sure to import our CSS for this component. So we'll say import newTodoForm.css. And let's go back and do this for todoListItem. Import todoListItem.css. And we'll do it for our todoList component as well. Import todoList.css. Okay, so now that we have our todoList, todoListItem, and newTodoForm components created, there's just two more things that we have to do before we can run our app and see these new components in action. The first thing we have to do is open up our app.js component, and instead of displaying hello world here, we're going to display our to-do list that we created. So in order to do that, we just have to say import to-do list from ./todos/to-do-list, and then replace this with to-do list. And then we're going to open up our to-do list and add the newTodoForm component at the top of that. So we're going to say import newTodoForm from ./newTodoForm and put that at the very top here. And in order to prevent our app from getting an error, we're going to have a default value for our to-dos prop here. And that should be all we need for now. If we run npm run dev and open up our app, we see that it's definitely displaying the newTodoForm, but since we don't have any actual to-do items in our application, it isn't displaying anything for that yet. Oh, and if you're wondering why the app looks so fancy, that's because I added in the styling that you can find in the exercise files. So in order to just get a taste of what our app is going to look like, let's add an object to this default value here, and it'll have a text property, and it'll just say hello. And if we go back to our app now, we see that this is now displayed as a new to-do item using our todoListItem component that we created. And that's all we have to do for now. Obviously, these components aren't exactly functional yet, since we haven't hooked them up to anything. But throughout the coming chapters, we'll see how we can use the React ecosystem tools to bring this application to life. The first React ecosystem tool we're going to be looking at here is something called Redux. Now, before I give you the details about what Redux is and how it works, let's take a look at the problem that Redux aims to solve. This should do a good job of answering one of the most common questions that people tend to ask when they learn about Redux, which is, well, why should I use that? So the question that Redux aims to answer is an extremely common one, and that is, what's the best way for us to manage state in our application? This can often be one of the hardest things to figure out in React applications, since there are so many options, each with their own pros and cons. For example, we could take a rather extreme position and have one central state contained by the root component, and then have it pass down pieces of that state to all its children. But this is usually a pretty bad idea, since once our app reaches any kind of size, we'll have to deal with an immense amount of what's called props drilling. And that's when we have to pass props through a component that doesn't actually use them, but just passes it on to its children. Now, I've seen apps where there are many levels of props drilling. The root component passes props to a page component, the page component passes these props onto a section component, the section component passes those props onto a list component, and finally, that list component passes those same props down to a list item component. Now, not only is this ugly, but it can be very frustrating to troubleshoot since sometimes a developer can inadvertently break this prop chain by mistyping the name of one of the props or something like that, which leaves them wondering why some value in one of the child components is undefined. So it's clear that a single state contained by the root component is probably not the way to go. So what if we went all the way in the opposite direction and just had each component manage its own state? After all, this would avoid the problem of props drilling. But now we run into another problem. What if components that are far away from each other in the DOM need to share data, as they most likely will? For example, what if somewhere down in the component tree we have a button component, and we only want that button to be enabled if all the pieces of a form component somewhere else in the component tree are filled out? Well, really our only choice here would be to hoist the state all the way up to whatever parent component those two child components have in common. But this leads to a rather unpleasant situation where you're never quite sure where in the component tree to find the state for a given component. It could literally be in any of its parents depending on the needs of the rest of the other components of the app. So it's clear that the two choices that we just went through are much less than ideal. But what other options do we really have? Well, a pattern that would seem to solve both the problems we've seen so far, the problem of props drilling and the problem of how to properly share state, would be to have what's referred to as a global state, a single centralized state that all components have unrestricted access to. So there's no props drilling because components can just access whatever data they need directly, and there's no problem sharing state since by default, all components share the entire state in this situation. Now this might sound great in theory, but in practice it can be a nightmare. And here's why. There are no rules for how to actually interact with or access the state, so what you end up with in all but the most disciplined code bases is an application filled with these transient, hard-to-recreate bugs that occur because of inconsistencies in the state. Just trust me here, an unrestricted global state is generally not something you want. So then, with the exception of the lack of rules and the subsequent chaos when using a global state, having a global state does solve the other two problems we mentioned, sharing state and excessive props drilling. So what if we were to take this idea of global state and solve its main problem by adding some strict rules and organization to it? Well, in fact, that's exactly what Redux aims to do, and in a minute we're going to take a look at just how it does this. Now that we have a pretty good idea of the major problems Redux was created to solve, namely props drilling, state sharing, and global state chaos, let's take a look at how it actually works. While the name Redux might intimidate a lot of people, as names that end in X tend to do, it's actually a fairly straightforward concept and process. Earlier, we learned about both the benefits and, perhaps more importantly, the rather crippling drawbacks of having a single unrestricted global state that's accessible by all of our components. That being said, one of the core concepts of Redux is that we have one central global state called the store that all our components can access. Now this store is essentially a big JSON object that serves as a single source of truth for all of our components, and in theory it can hold any kind of data that we need it to, although in practice there are some things that are better off without it, but that's a discussion for another time. So for example, our Redux store can hold data about the user, such as whether or not the user is logged in, the user's name, age, and bio, and whatever other data we might load from the server. It could also hold things like a list of products on an e-commerce site, or a list of articles on a blog site. Basically anything that we load from a server or any internal application state that we need to keep track of can be put into the Redux store. So the next question here is, since Redux uses a global state, how does it prevent the chaos inherent in this approach? Well, the problem with a global state isn't the fact that it's global per se. The problem is that there's no good way to control the access and modification of this global state by pretty far-flung parts of the application. This means that with an unrestricted global state, any part of our application can make whatever changes it wants to the global state, basically without any restriction whatsoever. So we'd be relying on all of our components to be good stewards of this state and change it in predictable ways, which, from a software development standpoint, is a very naive assumption. So in order to see how Redux solves this problem, let's take a look at the two other pieces of the Redux flow. We've already talked about the Redux store, which contains the current state of our application, but in addition, we have Redux actions and something called reducers. Let's discuss both of these in turn. Redux actions are JSON objects consisting of two things: an action type, which is basically just a string naming the action, and a payload of additional data. The purpose of Redux actions is to explicitly define the different events that can occur in our application. So for example, we could have an action with the type user_data_loaded, with a payload that contains the actual user data that we just fetched from the server. Or we could have an action with the type item_added_to_cart, with a payload that contains the ID of the item that the user just added to their shopping cart. Now obviously the number of possible actions in an application can be pretty large, but the point here is that we're explicitly defining them instead of just leaving it to chance. So that's actions. Reducers, on the other hand, are Redux's way of specifying what should happen to our Redux store, our central state, when a given action occurs. So using our example from before, we might say that when a user_data_loaded action occurs, we set the user property in the Redux store to the user data that's in the action's payload. Or when an item_added_to_cart action occurs, we add whatever item is in the payload to the array of items in the shopping cart property of our Redux store. So the key point to know here is this: our components are only allowed to make changes to the state by triggering these predefined actions, and the only changes to the state that are allowed to take place in our application are the corresponding changes that we specify in our reducers. This all gives rise to what's referred to as a unidirectional data flow. In other words, we end up with a cycle that looks something like this. The UI triggers an action, that action is reduced to get the new updated state, and the components in our application get read-only access to that updated state. We'll go into more detail about this in videos that follow, including what this all looks like in code and how components can access our store and trigger actions. Now that we know what problems Redux is meant to solve and the basic concepts behind how it works, let's walk through the process of actually adding Redux to our project. As a matter of fact, adding Redux to our project is really a simple process with only a few steps. So the first thing we're going to do is actually install Redux into our project, and to do that we just need to open up a terminal inside our directory and run npm install redux and react-redux and hit enter. And once we've done that, the next thing we're going to do is create a new file inside our source directory called store.js. This is where we're going to put our logic for setting up our Redux store. So we'll say store.js. And for now, this file is going to be pretty simple. We'll add more stuff to it as we create our actual reducers and add new ecosystem tools to our project. First, we're going to import two things from Redux. We're going to say import create store and combine reducers from Redux. And then down below that, we're going to define an empty object called reducers. So const reducers equals empty object. This is where we'll put all the reducers that we define later on, but for now it's just going to be an empty object. So once we've done that, we have to use the combine reducers function that we imported to create what's called a root reducer. So we'll say const root reducer equals combine reducers. And all this does is put our reducers into a form that we can pass to the create store function that we imported. So what we're going to do down here is export a function called configure store. We'll say export const configure store. And it's going to simply return create store called with the root reducer we created. And that's all the setup we need inside our store.js file for now. The next thing we need to do is open up our Index.js file and wrap our whole app inside what's called the Redux provider. So let's open up Index.js. And the first thing we've got to do is import our provider. So we'll say import provider from React-Redux. And we also need to import the configure store function that we just defined in our store.js file. So we'll say import configure store from store. And then inside this react-dom.render function, we're going to wrap our app component with this provider and pass our configured store into it. And that's going to look like this. We're going to wrap our app component in the provider, and to this provider component, we're going to pass a store prop, and we're going to pass configure store called. And then we're just going to put this app component inside the provider here. And that's all the basic setup we have to do for now. The next step for us is to create our actions and reducers, and once we've done that, we'll come back to our store configuration and see how everything fits together. Now that we've performed the basic setup to add Redux to our React app, we're going to actually create some actions and reducers that our application can use to help keep track of its state. In this video, we're going to start off by defining some Redux actions. So the first thing we're going to do is create a new file inside of our source/todo directory, and we'll call it actions.js. And then inside this file, we're going to define a create-to-do action that our app will fire whenever the user types something into the newTodoForm component that we created and presses the create-to-do button. We'll see how this all fits together later. So we saw in a previous video that every action is essentially just a JSON object with a type property and possibly a payload. And because of this, we're going to start off by creating a constant for the action's type. We're going to say export const create to do, all capital snake case, and that's going to be equal to just the string create to do. And once we've done that, we're going to create the actual action that our components can dispatch. Now, our first instinct might be to say something like export const create to do equals type create to do, something like that, just exporting a JSON object. But as we'll see later on, this action is going to need to have a payload as well, which will contain the text of the new to-do. So instead of just exporting a JSON object, what we're going to do instead is export a function that takes this extra info as an argument and returns an action object with this info as the payload. So what does that look like in code? Well, we're going to say export const create to do equals text, and this is going to be a function that simply returns an object with the type create to do that we created. And the payload will be an object with the property text. And that'll contain the text of the new to do when we trigger it. So again, the idea is that when we trigger this action from our components, we're going to just call this create to do function like this and pass it the text of the new to do. Now, there's a name for functions like this that create our action objects for us. They're called action creators. And notice I didn't say it was a very creative name. The nice part about using action creators is that they abstract away all the actual code for the actions. As we'll see later on, inside our components it's much easier and less error-prone to simply use these action creators than to explicitly code out the action objects. And for this reason, in React-Redux applications, we work almost exclusively with action creators instead of using bare actions, even when a given action doesn't even have a payload. In this case, we would still create an action creator, it just wouldn't have any arguments. So that's our first Redux action type and action creator that we'll be making use of when the user enters a new to-do item and clicks create to do. What we're going to want also is an action type and action creator for when a user wants to remove an item. And here's what that'll look like. We'll start off by creating another action type. We'll say export const remove to do equals remove to do. And then we're going to define the remove to do action creator. Note that in a coming video, we're going to make it so that the create to do form prevents users from entering duplicate to do item text. So for now, we can just use the text of a to do item as a unique identifier to delete it. Not necessarily ideal, but for now that'll work just fine. So our remove to do action creator is going to look like this. Export const remove to do equals, and then we're going to be using the text as the unique identifier, And the type of the action we create is going to be remove to do. And the payload will simply be an object with the to-dos text that we want to remove. And that's all there is to it. We've got our first two action types and action creators. In a little while, we'll go into more detail about how to actually use these. Now that we've defined our actions for creating and removing to-dos, let's see how to define a reducer that will keep track of the state of the to-dos in our application, as well as behave appropriately when our components trigger one of these actions that we just defined. First, let's create a new file in our to-dos directory called reducers.js. And this, as you may have guessed, is where we'll put our reducer code. So let's talk about what a reducer should look like and how it works exactly. Well, at its core, a reducer is just a function named after whatever resource in the Redux store it's in charge of managing. So for this reducer, we're going to define it by saying export const, and we're going to call this reducer todos. And reducers take two arguments. The first one we'll call state, and the second one we'll call action. And it's going to be a function. So here's how reducers work. Every time any action is fired from anywhere in our application, our reducer will get called. When this happens, the two arguments that will get passed to a reducer are the current state of whatever resource the reducer is managing. In this case, it'll be an array of the current to-do items in our application. And the second argument is the action that was triggered, which will be an object with type and payload properties. So what reducers do is take the current state and the action that was triggered and decide what changes should occur in the state as the result of this action. And they should then return the updated state, and Redux will take this return value and set the current state to that. Don't worry if that doesn't make sense quite yet. We're going to go into much more detail. So the simplest possible reducer for us would be if we were to just say return state, since no matter what action or state this reducer was called with, it would make absolutely no changes. However, we'll usually want our reducers to be a little bit more complex than that. The actual meat of our reducers will almost always be a switch block that looks at the type of our action. So first, up at the top of our reducer, we're going to say const, type, and payload, and get those properties from the action that our reducer got called with. And then what we're going to do is have a switch block that looks at the type of the action and decides what to do based on that. So we're going to use this switch block to make the to-dos reducer respond correctly to our create to-do and remove to-do actions. In order to do that, we have to import the create to-do and remove to-do types. So import create to-do and remove to-do from actions. And then we're going to add cases to both of these action types to our switch block, and that'll look like this. We'll say case create to do and case remove to do. And now that we have that, we just have to think about what we want to happen to our to-dos state, which is going to be an array, remember, when either of these actions occurs in our application. Well, when a create to do action occurs, we'll want to get the text property from the payload, which will look like const text equals payload. And remember that we defined the payload like this when we defined our create to do action creator, right here. And the next thing we'll want to do is create a new to-do item, const new to-do, with the text that we got from the payload, as well as an isCompleted property that's set to false initially. And finally, we'll want to return the current state, which is an array of our current to-dos, return state, with this new to-do concatenated onto the end. So we'll say return state.concat new to-do. And note also that this concat method, when called on an array, doesn't actually mutate the array. When working with reducers, it's very important that we're careful not to mutate the state in any way, because this will cause problems down the line. So that's the logic for our create to do action. Let's do something similar for our remove to do action. For this one, we're going to get the text from the payload again. We'll say const text equals payload. And then what we're going to do is we're going to return the state. We're going to say return state with the to-do that we want to remove filtered out. And here's how we do that. We say state.remove filter to-do, and we only want our to-dos whose text property does not equal the text property that we got in the action payload. So that's the logic for our create to-do and remove to-do actions. Last but not least, we'll want to add a default case to our switch block, and for the default case, default, we'll simply want to return the state. The reason we do this is because our to-dos reducer will get called whenever any action gets triggered in our application. If our switch block makes it to the default case, that means the action that was triggered wasn't one that we're really concerned with, so we should simply return the state as it is. And we're going to want to remove this return state at the bottom. Now, once again, it's important to note that we do have to remember to return the unchanged state if our reducer doesn't make any changes, since otherwise, to Redux it'll look like our reducer is returning undefined and it will throw an error. Oh, and one last thing. Let's set the default value of our reducer to an empty array. The way we do that is by saying state equals empty array up in the arguments. And that's it for our reducer for now. Now that we have our to-dos reducer defined, we just have to actually add it to our application's store. And to do that, we just have to open up our store.js file, and we're going to import our to-dos reducer that we just defined. Import to-dos from todos/reducers. And we're going to add our to-dos reducer as a property of this reducers object here. And that's it. Our to-dos reducer is now hooked up to our Redux store. So far, we've defined some of the possible actions that can happen in our application and the effects that they should have on the state of our application when they're triggered. The next step is to actually give the components in our application access to the Redux store so that they can see what the current state is, as well as trigger actions that modify the state. The way we do this is by doing what's called connecting the components to the Redux store. And to do this, let's open up one of our components. We'll start with newTodoForm. And up at the top, we're going to import a function called connect from the React-Redux package. Import connect from React-Redux. So here's how we use this connect function. Connect is what we call a higher order function, which in this case simply means that we call it with two different sets of arguments. Something like this. Don't worry too much about the details of higher order functions here. So the argument that we pass to the second set of parentheses is the component that we want to connect to the Redux store. In this case, it would be newTodoForm. And what connect does is return a so-called connected version of that component. So instead of exporting our regular component here, we're going to be exporting our connected component that we define. So let's do that down at the bottom here. Instead of saying export default newTodoForm, we're going to say export default connect, first set of parentheses, and second set of parentheses around newTodoForm. So now that we've done that, we've seen that we pass the component we want to connect to the second set of parentheses. The arguments we pass into the first set of parentheses are where things get interesting. We're going to define two functions, one called mapStateToProps. We'll say const mapStateToProps, and it's going to take an argument called state, and for now it'll just return an empty object. And we're going to define a second function called mapDispatchToProps, which takes an argument called dispatch, and for now this is going to return an empty object as well. And then we're going to pass these two functions, mapStateToProps and mapDispatchToProps, to the first set of parentheses of connect. mapStateToProps, mapDispatchToProps. So what do these two functions do exactly? Well, let's start with mapStateToProps. The state argument that gets passed to mapStateToProps is an object that represents the entire Redux state. In our case, it'll only have a todos property so far, but in larger applications it could contain a pretty large number of properties representing different pieces of data in our applications, such as users, videos, articles, and a lot of other things. Now, the job of mapStateToProps is to take this state object and return another object containing the pieces of that state that our component needs access to. So in our case, we'll want our newTodoForm to have access to the to-dos in our state, which will look like this. We'll return an object with the property todos that's equal to state.todos. And the cool part here is that because we passed both map state to props and our newToDoForm component to this connect function, newToDoForm will now automatically get the to-dos from the state passed to it as a to-dos prop. So we can add that up top here. And don't worry too much if this doesn't make complete sense yet. We'll be getting much more practice with this. So that's map state to props. Now let's move on to map dispatch to props. This function works in a similar way to map state to props in that the properties of the object that we return will be passed to our component as props. The difference here is that instead of taking the Redux state as an argument, it takes something called dispatch. Now, what dispatch is it's a function that allows our components to trigger actions that our Redux store will respond to. In our case, we want to trigger a Redux action when somebody clicks the Create To-Do button of our newToDoForm. So here's what we're going to do. We're going to start off by importing our Create To-Do action creator up top here. We'll say import Create To-Do from actions. And then from this map dispatch to props function, we're going to pass our component a prop called onCreatePressed. And this is going to be a function that takes an argument called text and calls dispatch. And the action we're going to be dispatching is our create to do, called with the text argument, which will create a proper action object for us. And then we want to add this to our newToDoForm's props object. On create pressed. And at this point, our component has all the access it needs to the Redux store. It can see the to-dos that are currently in the state, and it can dispatch an action to the store when we want to create a new to-do. All that's left right now is to make use of these two new props. So we're going to add some functionality to the onClick method of our create to-do button. What we're going to do is add an onClick method to our button, and we're going to define an anonymous function here. And inside it, we're going to call our onCreatePressed prop with the current value that's in our text box. Remember that earlier we defined this input value state variable to keep track of the value that's in our input box. So we're going to call onCreatePressed with input value. And then after that, we're going to clear the contents of our input box by calling setInputValue. Remember we defined that up here in a previous video. With an empty string. Now, I mentioned earlier that we want to prevent the user from entering duplicate to-do text. So let's define a constant here called isDuplicateText. Const isDuplicateText. And we're going to use array.sum to see if there's already a to-do that contains this text. This will make use of the to-dos prop that we're now passing to our newToDoForm component. So we'll say todos.sum, to-do, and we want to check if any of the to-dos in our state has text that's equal to the current input value. And now that we've defined isDuplicateText, we're going to create an if statement here. We'll say if is not duplicate text, then we want to do these things. Otherwise, we don't want to do anything. So we'll copy and paste those two functions. Our newToDoForm is fully taking advantage of Redux at this moment. Now that we've seen the basics of how to connect components to the Redux store, there's one more important component that we need to do this with right now, and that's the todoList component. As it stands right now, we can create new to-do items with our connected newToDoForm component, but those changes won't actually be reflected in our to-do list since it's not yet connected to the store. And while we're at it, we still have to make the remove and completed buttons in our todoListItem component do something. In this video, we're going to take care of the remove button, and then making the completed button work will be a challenge and solution video, so stay tuned for that. Okay, so let's connect our to-do list to the Redux store. The flow for this is going to be very similar to what we did for the newToDoForm. We're going to start off by importing connect. So up here we'll say import connect from React-Redux. And then down at the bottom here, instead of just exporting our base to-do list component, we're going to say export default connect parentheses parentheses. And the next thing we do is define our map state to props and map dispatch to props functions to pass to connect. So we'll say const map state to props equals state. And for map state to props, we just want to get the to-dos from the state, just like we did with our other component. And that'll look like this. We'll say todos state.todos. And then we're going to say const map dispatch to props equals dispatch. And we're going to return an object with the property onRemovePressed. And we're going to need to go up to the top and import our removeToDo action creator that we created earlier. Import removeToDo from actions. And then our onRemovePressed property here will just be a function that takes the text of the to-do item we want to remove as an argument, and then it dispatches that removeToDo action with the to-do's text. And let's pass these two functions to connect. Map state to props, map dispatch to props. And there we go. Our to-do list is now connected to the Redux store. Now, real quick before we move on, I just want to point something out to you. For the two components that we've done so far, when we've connected them, we've had both a map state to props and a map dispatch to props function. However, this isn't always the case. There are plenty of times when the component we're connecting will only need one of those two functions. And if that's the case, we simply define only one of these functions and pass it to connect. If we were to only need map state to props, for example, it would just look like that. And if we were to only need map dispatch to props, we would pass null for the first prop. So that's just something to keep in mind when connecting components. Anyway, now that our to-do list is connected, we can access these two new props that it's getting from connect. So we already have to-dos up here. We're going to add in the onRemovePressed function that we defined. And then what we're going to do is, inside where we map our to-dos to to-do list items, we'll pass this onRemovePressed function down to each item as a prop, like this. We'll say onRemovePressed equals onRemovePressed. And then we need to open our todoListItem.js file and add this onRemovePressed to the props up top. So we'll say onRemovePressed. And then for our remove button here, we're going to add an onClick method. OnClick. And we're going to say that when the button is clicked, it should call onRemovePressed with the text of the to-do. OnRemovePressed to-do.text. Okay, and that should do it. Let's try running our application now to see if it works as expected. We'll say npm run dev. And let's open up our application and try adding a to-do. And we see that creating a to-do works fine. And if we click the remove button, we see that that works as well, which is fantastic. We now have a functioning React application that uses Redux to keep track of its state. Even though our app so far is a pretty limited little to-do application, this is a pretty big achievement still. One thing that we do need to address, however, is that our application works quite well for adding and removing to-dos, but when we refresh the page, as a user might sometimes do, our entire Redux state is lost and starts over from scratch. And this is definitely not ideal, but unfortunately there's a fairly straightforward way to do this, and in this video, we'll see exactly how. So to ensure that the state of our application is kept through a browser refresh or some related event, we'll be using something called Redux Persist. The first thing we're going to do is install this package by running npm install redux-persist. And once we've done that, we need to make a few changes to our store.js and index.js files. We'll start off with store.js. There are three main things that we have to import up at the top here, and we'll see what each of these does in a minute. First, we're going to say import persist reducer from Redux Persist, import storage from Redux Persist /lib/storage, and import auto merge level 2 from Redux Persist /lib/auto /state reconciler /auto merge level 2. So now that we've done that, the next thing we're going to do is underneath where we define our root reducer here, we need to define a new constant called persisted reducer, and then wrap our root reducer using the persist reducer thing that we imported. And that'll look like this. We'll say const persisted reducer equals persist reducer, and then something called persist config, which we'll get to in a minute, and our root reducer. So we haven't defined this persist config here yet. All this is an object that tells Redux persist how to save and where to store our application's data. And it's going to look something like this when we define it. We'll say const persist config equals, and it's going to be an object, and it's going to have a key property that we'll set to root, and it's going to have a storage property. We imported storage up here. This defaults to local storage on the web, which is exactly what we want. And last but not least, we're going to have a state reconciler property that we're going to set to auto merge level 2. And what this auto merge level 2 thing does is it tells Redux persist how to reconcile the initial and stored states of our application, as in how deep should it go when doing so. And the last thing we need to do in this file is, instead of passing root reducer to create store, we need to pass this persisted reducer that we defined. So we'll remove that and say persisted reducer. Okay, that's it for store.js. Let's move over to Index.js and add Redux persist there. So open up Index.js, and we're going to start off with the imports again. So up here we'll say import persist store from Redux persist, and import persist gate from Redux persist /lib/integration/react. And now that we have those two things, here's what we're going to do. First of all, instead of calling configure store right here in our provider, we're going to define it as a separate constant. So we'll say const store equals configure store, and pass that to our provider instead. And then underneath store, we're going to define something else called a persister by saying const persister equals persist store. And now is when we're going to use this persist gate thing that we imported. What we're going to do is we're going to add this persist gate as a layer in between our provider and our app. That'll look something like this. We'll say persist gate persister equals persister, and then put our app inside of that. And there's one more prop that we're going to add to our persist gate, and that's something called loading. And what this is going to be is the view that Redux persist displays instead of our application while it's loading our application data. So for now, we'll just have that be a div that says loading. We're not going to get too fancy with it here. And that should be it. If we start our app by typing npm run dev, and then navigate to a browser, let's try adding some to-dos, and then refreshing our page, and we see that it no longer erases all our data. The same is true if we navigate to another website and then come back to this one, for example. And this is all very helpful. So now that we've persisted our Redux store, there's just one more thing I want to show you. While persisting the store is most often a very helpful thing, during development it can sometimes lead to what developers call permacrash, where the state is screwed up with relation to our app, and our app keeps crashing because of some error. If this happens to you, all you have to do is delete the persisted data from local storage or wherever else you're storing it. And here's how you do that in Chrome. It might be different in other browsers. We're going to open up Inspect, and then we're going to go to the Application tab. And down here where it says Local Storage, we're going to open that up and click on this. And you see this persist root thing here? That's where our app is storing the persisted state of our application. So what we're going to do is simply delete this. And now that we've done that, if we refresh our application, we see that we're starting with a fresh state. So that's just a helpful thing to know how to do. So far, when working with Redux, we've had to sort of blindly develop and rely on the state of our components to show us what's actually in our Redux store at any given moment. However, there's absolutely no reason we shouldn't be able to simply look directly at the state of our application at any given moment. In order to do this, we can use something called Redux DevTools. So the first thing we're going to do here is install Redux DevTools into our browser. I'm going to show you how to do this with Google Chrome, but the process should be pretty similar with any other browser. The way I usually find it is by just Googling Redux extension Chrome, clicking on the first link, and then when that comes up, I just click Add to Chrome and click Add Extension. And once we've added that to our browser, what we're going to do is go back to our code and open up our store.js file. And there's something we need to add to create store in order to make this work correctly. So the persisted reducer is still going to be the first argument to create store, but we're going to pass another argument to it, and that's just going to look like this. It's going to be window dot underscore underscore redux underscore devtools underscore extension, and then 2 more underscores, and then and we're going to copy and paste this whole thing because it's a pain to type out, and put 2 parentheses, and that is about it. All this does is actually connects our app to the Redux DevTools extension that we just installed while it's running in our browser. So what we can do now is run our application, npm run dev, and you're going to want to refresh this just to make sure that the changes that we made take effect. And we see here that the little Redux DevTools extension at the top lights up. And if we click on it, we'll see a collection of Redux tools. Now these can all be incredibly helpful things while developing applications with Redux. First of all, we can see the state of the entire store of our application at any given moment by going to the State tab. And over on the left, you can also see all the actions in our application as they're triggered. So if we add a new to-do here, and create it, and go back to our Redux DevTools extension, we can see when this action was dispatched, as well as the difference it caused in the state, and the entire state after that action fired. So we can see our new to-do in the store. And this is all very helpful, since it means that we don't have to have implemented all our components in order to see what's in our Redux store. We can just look at it directly. Now, another cool thing that we can do is use this tool to trigger Redux actions with specific properties. So if we wanted to make sure our to-dos reducer was set up correctly for creating new to-do items, we can open up the dispatcher at the bottom here, the one that looks like a little keyboard. And in the text box, what we enter is something like create to-do, and payload, text, this is a test, and hit this dispatch button down in the corner, and we see that it actually dispatches that action to our application. So the point here is that this is just a very helpful tool when developing React-Redux applications. And if you want to see a larger version of it, you can also hit Inspect, and see the Redux DevTools extension over in its own tab. So in this section, we've seen how Redux works and the basics behind incorporating it into our React applications. Now, what we've done may seem relatively straightforward to you, but in practice there are many questions that come up when using Redux, and frankly there are many, for lack of a better word, wrong, ways to do things when working with Redux. In this video, we're going to look at a few of what I would consider best practices when working with React and Redux. Things to keep in mind to ensure that your React-Redux applications work as expected and remain maintainable for the foreseeable future. The first of these best practices is when you connect components to the Redux store, your file should export both the unconnected and connected versions of that component. The reason for this is that the connected version of your component is usually what the rest of the application will want to use, but when testing your component, which is something I highly recommend by the way, it'll make your life a lot easier if you can simply test your component as is without having to create and set up a fake store in order to see how your component behaves under different circumstances. So really what I'm saying here is that from the point of view of your tests, it should be completely irrelevant if your component is actually connected or not. Your test should simply check to see whether or not your components render the correct JS given a specific set of props. The second best practice when working with Redux is that you should never trigger any other actions from inside your reducers, or perform any kind of asynchronous operations such as fetching data from the network. I'm not going to go into too much detail about this here, but there is definitely a more correct way of doing these things, and we'll see exactly what this is very soon. For now, it's just important for you to remember that reducers are specifically meant to take the current state of the Redux store and combine it with an action to get the updated state, and that's it. The third Redux best practice is that we need to put some thought into which components we connect to the Redux store in our application. To be a little more specific here, we need to realize that connecting a given component to the Redux store has the potential to make that component less reusable from the point of view of the rest of our application. As an example, think about the TodoList component that we created earlier in the course. Right now, it's hardwired to display all of the to-dos in our Redux store. And this works, since that's how our application is designed right now, but what if we wanted to reuse this to-do list elsewhere in our app and display different collections of to-dos? For example, what if we wanted to have two separate lists, one that displayed all the completed to-dos, and one that displayed all the incomplete to-dos? In this case, it wouldn't make as much sense to have our to-do list component connected to the store. It would make more sense to have some parent component that was connected to the store and have it simply display two identical to-do lists, but with different data. All of the completed to-dos for one, and all of the incomplete to-dos for the other. So, in other words, we should avoid connecting components to the store if we plan on reusing them throughout our app with different data. Instead, we should have some kind of parent component that's connected to the store and passes the correct data to these reusable components. Well, those are my top 3 best practices to pay attention to when using Redux in a React application. Obviously, there are many, many more, but what I've personally found is that at the end of the day, the most foolproof best practice is to use Redux a lot in many different situations and figure out what works best for you and what doesn't. This and this alone will give you a powerful intuition that'll help you use Redux to its maximum potential in whatever application you're building. Now that you've seen most of the basics of incorporating Redux into a React application, it's time for a little challenge. In previous videos, we implemented the entire Redux flow, action types, action creators, and reducers for 2 actions, creating and removing to-dos. One of the things we haven't done yet, however, is implement this flow for marking a to-do item as completed, and that's your challenge here. Your task is to create the flow for marking the to-do as completed, including the action type and action creator, adding a case to our to-dos reducer to handle this action, adding this action to our connection logic, and finally hooking it up so that the correct changes to the state are made when the mark as completed button is clicked. So that's your basic task. To be even more clear, here's what should happen. When the mark is completed button is clicked on a to-do item, the state should be modified so that the isCompleted property for that item is true. And as a further hint, you'll probably want to use the to-dos text as a unique identifier, just like we did with remove to-do. And just one last thing before we begin the challenge. In order to make it visible that a to-do has been completed, since we currently have nothing here that indicates this, why don't we use a to-dos isCompleted property to either show or hide the mark as completed button? That's fairly simple to do. It just looks like this. We're going to have a bracket and say to-do.isCompleted, and we'll just use a ternary operator here. And if a to-do is completed, we just want to return null here. And if it isn't, we want to show the mark as completed button. And let's add the closing bracket to the end here. And that's it. This challenge should take you about 10 minutes. When you've given it a try, feel free to move on to the next video where I'll show you how I solve this challenge. Okay, I'm going to show you how I solve this challenge. Keep in mind that the code I'm going to write in this video will continue to be a part of this project, so if you did yours a little differently, you might want to rewrite it to make it more similar to mine, or just keep in mind that things like variable names in your project might be a little different going forward. So with that in mind, I followed a very similar flow as what we used for removing and creating new to-dos. I started off with actions.js, and I added a new action at the bottom. I started off by creating an action type. I said export const, mark to do as completed, and set that equal to a string, mark to do as completed. And then I made the action creator, export const, mark to do as completed. And I made that take the text of the to-do that we want to mark as completed as an argument. So text, and then that's going to return an action with the type mark to do as completed, and a payload which has an object with that text property in it. So now that we've got the mark to do as completed action creator and action type, I added a new case to our reducer. So I opened up reducers.js, and underneath the remove to do case, I added another case. I said case mark to do as completed. And then of course we have to import that too. And inside this case, I got the text property from the payload, very similar to what we've done with the other actions. Const text equals payload. And then what I did is I said return state, and then I mapped each to-do item. I said state.map to-do, and if the text of that to-do, if to-do.text was equal to the text of the payload, then what I did was returned the to-do with the isCompleted property set to true, which looks like this using the spread operator. Return ... to-do is completed true. Otherwise, for the rest of the to-dos, I just left them untouched. And that's pretty much it for the reducer. After that, I opened up todoList and imported the action creator that we just made. So I add mark to do as completed. And then down here in map dispatch to props, I added a prop called on completed pressed. And what that did was take the text of a to-do and dispatch our mark to do as completed action with that text. And then I went up to the top here and added that to the props of todoList. And what I did then was simply pass that onCompleted pressed function down to the todoList items. OnCompleted pressed equals onCompleted pressed. And then the last step in hooking up this flow was to open up todoListItem.js, add the onCompleted pressed prop that we're passing to it, and add that to the onClick method of our completed button. OnClick equals onCompleted pressed with the text of the to-do. And that should be pretty much it. If we run our application now by saying npm run dev and open it up in a window, and you may have to refresh it because we made some pretty big changes. We'll say hello. And if we click on mark as completed now, we see that that button disappears, which means that that to-do is now completed. Congratulations if you figured out how to do that. Previously, we saw how adding Redux to our React application furthered our goal of separation of concerns by giving us a centralized, controlled way of managing state through actions and reducers. And basically what this means is that our components no longer have to worry about controlling their own states. And this is great, since it means that the business logic for what sort of state transformations are allowed to take place and how they take place is no longer contained inside of our component files. And this simplifies our components conceptually, as well as in terms of the number of lines of code they contain. However, even with Redux in place, our components still have to contain the logic for doing all the asynchronous operations, such as fetching or updating server data. We call these sorts of operations side effects. Now, conceptually, we want our components to have only one concern: correctly displaying the data we give them. So these side effects should be moved out of our components if possible, and of course it is possible by using what are referred to as side effect libraries in our applications. There are several side effect libraries that are available to React developers. Two of the most popular ones are Redux Thunk and Redux Saga. Now, despite the somewhat cryptic names, the goal of these side effect libraries is more or less the same: to give us a way to separate the side effects of our application from our components. So in terms of relative popularity, that is, in terms of GitHub stars at least, Redux Saga is in a pretty big lead. However, because of the relative simplicity and smaller learning curve of Redux Thunk, we're going to be covering Redux Thunk in this course. But just understand that if at some point in the future you want to look into Redux Saga or some other side effect library instead, they're all used to solve roughly the same set of problems as Redux Thunk. So now that we know the basic goal of Redux Thunk, how does it work exactly? Well, basically, Redux Thunk works by sort of tapping into the normal Redux data flow. That is, if we have our normal unidirectional data flow where our components trigger actions, those actions cause predictable changes to the data in our Redux store, and these data changes are then reflected in our components, Redux Thunk allows us to add a sort of fork into this loop where we can put the logic for our side effects, whether that's loading data or performing some other asynchronous operation. So what this looks like more or less is that our components can dispatch a regular Redux action, which goes straight to the reducer and makes the relevant changes to the store, or our components can dispatch a thunk that performs whatever async or conditional operations we want, and then dispatches its own Redux actions based on the result of those operations. That might sound a little confusing, so let me give you an example of how this might be used in a React-Redux application. Let's say that we have a user profile page, and we want our app to load a user's data from the server when the page is opened. Now, without Redux Thunk, the way we might do this is by putting our fetching logic in the component-did-mount lifecycle method, or by using a useEffect hook, and then, once the data is loaded, we dispatch a loadUserSuccess action with the new data that we loaded. Or if the fetching failed for some reason, we dispatch a loadUserError action that might set some error flag in our Redux store. So this works, but again, the loading logic doesn't really belong inside of our components. We should strive to keep our components as focused as possible on their purpose, taking data and rendering it. And here's where thunks come in. Remember in previous videos when we defined Redux actions, that Redux actions are just objects that contain a type property, and perhaps some other data in the action's payload. When we dispatch a Redux action, Redux calls our reducers with this action, and the reducers determine what the state should look like afterward. So what a thunk is when instead of dispatching a Redux action, which is again just a JavaScript object, we pass a function to dispatch, and this function is where we put whatever async operations we want to perform, such as loading data. And we can also dispatch other actions or even other thunks from inside this function. We'll see just how to do this in a later video. So then, as I said before, thunks basically add a fork to our basic unidirectional data flow. Instead of dispatching only bare Redux actions, our components can also dispatch thunks, which perform asynchronous operations and can dispatch their own actions or thunks. And the point of all of this is that it allows us to almost completely remove our side effect logic from our components, thus increasing our separation of concerns. So now we know some of the basic theory behind what Redux Thunk is and how it works. Don't worry too much if it doesn't make complete sense yet. We'll see some examples very soon. In this video, we're going to add Redux Thunk to our project. So let's start off by installing the packages we'll need. Open up a terminal inside our projects directory and type npm install Redux Thunk, which is the actual package for Thunk, Redux DevTools extension, which we'll be using to add the Thunk middleware to our Redux store in a nice, neat way, and Babel runtime, which we need to add to our project to make our asynchronous thunks work. So let's install those packages. And once we've done that, we're going to install just one more thing. We're going to say npm install save dev babel /plugin transform runtime. And this is the development version of the Babel runtime package we just installed. So hit enter and install that. And now that we've installed everything, the next thing we need to do is add the Babel plugin that we just installed to our Babel RC. So open up your Babel RC file. And what we're going to do is add a plugins property to the object. And it's going to be an array. And inside that array, we're going to say Babel, plugin, transform, runtime. And once we've done that, the last thing we need to do is open up our store.js file and add a few things to it. So up at the top, we're going to import some stuff. We're going to say import thunk from Redux Thunk. We're going to add apply middleware to our Redux import statement. And finally, we're going to say import compose with DevTools from Redux DevTools extension. And then down where we call create store, we're going to delete the lines where we add the DevTools extension. And in its place, we're going to add compose with DevTools. And inside those parentheses, apply middleware, thunk. Now, this won't do very much right now since we don't have any thunks yet. And that's the next thing we're going to do, add some thunks. Now it's time to create our first thunk. Inside our to-do folder, let's create a new file called thunks.js. And this is where we'll put the thunks for our project. So what does a thunk actually look like? Well, in Redux, a thunk is simply a function that returns another function which contains the actual logic that we want to perform when it's triggered. So for our first thunk, let's do something fairly simple. We're going to define a thunk called displayAlert. So we'll say export const displayAlert. And what it's going to do is simply return another function that displays an alert on the user's screen. So we'll say alert hello. So this is about as simple as thunks can get. We'll see later on how we can add a lot more functionality to our thunks, but first let's see how to dispatch a thunk. You might be happy to find out that the way we dispatch a thunk is nearly identical to the way that we dispatch actions. We dispatch them inside the map dispatch to props for a given component. So just as a demonstration, we're going to open up our to-do list component, and we're going to make it dispatch this displayAlert thunk that we just defined. So up at the top, let's import it. We'll say import displayAlert from thunks. And then inside map dispatch to props, we're going to define a prop that gets passed to our component, and we're just going to call this one onDisplayAlertClicked. And this is going to be a function that doesn't take any arguments, and when it gets called, it will simply dispatch the thunk we just created. So dispatch displayAlert. And then up at the top of our component, in the props, let's get access to this onDisplayAlertClicked prop. And just for demonstration purposes, we're going to replace the onCompletePressed method of the to-do list items with this onDisplayAlertClicked. So we'll go up here and replace onCompletePressed here. We'll say onDisplayAlertClicked instead. And now if we run our app, npm run dev, and open our app up in a browser, if we click on the Mark as Completed button for any of these to-dos, we see that it displays an alert using our thunk, which is pretty cool. So the thunk that we created here didn't take any arguments, but it definitely can if we want it to. If we go back and modify our thunk to take a text property, for example, we'll say text, and then in this alert, we'll use backticks and say you clicked on, and print the text. And then what we can do is go back to our to-do list component, and add this argument into our map dispatch to props function like this. We'll say text, and have displayAlert get called with text. And then what we can do is go back to our application and click on Mark as Completed, and we'll see that the text of each of our to-dos is now getting passed to the thunk. And those are the basics of how thunks work in a React application. Obviously, there are much more complex things that we can do with thunks, and we'll take a look at that shortly. For now, let's change back this component to the way it was before. So we'll delete this prop, delete this prop, and make it pass onCompletePressed again. In the previous video, the thunk that we created was extremely simple. It was also synchronous, since the actual operations performed by our thunk were synchronous. However, most of the time this is not the case. In a real-world web application, we'll be using our thunks for mmany different asynchronous tasks, such as loading or updating server data. we're going to take a look at how to create thunks that do this sort of work for us. But first, we need a backend that we can query from our React application. Now, I've created a simple node server for us to use in this course. In order to use it, you just have to download the project, and once you've downloaded it, you need to navigate to that directory using a terminal and run npm install. And once that completes, you need to run npm run start. And you'll see a message saying that the server is now listening on localhost port 8080. So, just to give you a brief overview of the server I've created for us, it's a very basic REST API that allows us to create, read, update, and delete to-do items stored in memory on the server. And I made it in memory so that you wouldn't have to worry about setting up MongoDB locally on your computer. So here are the basic things we can do to our server. We can send a GET request to /todos, which will send us back an array of all of our current to-dos. We can send a POST request to todos with a payload that contains the text, and the server will use this text to create a new to-do in its in-memory database. It'll also add a new unique ID property, as well as created at and is completed properties, and return the entire to-do item, complete with ID, text, is completed, and created at properties as the response to our request. We can also send a POST request to todos/ID/completed, which will mark a given to-do item as completed and return the updated to-do item as a response. And finally, we can send a delete request to todos/ID to delete the to-do with the given ID from our server's in-memory database. And this endpoint will send the to-do object that was deleted as a response. Now that we've seen all the endpoints of our Todos API, let's hook up our React application to this server by using thunks. The first thing we'll do is open up our thunks.js file, and we're going to create a new thunk. We'll say export const, and we'll call this one load todos, and it won't take any arguments, and it'll return an async function, which you're allowed to do here, and we're going to put our loading logic into this thunk. So before we implement the body of this async function that we're returning, there's something you should know about thunks. The function we return here gets passed 2 arguments when the thunk is triggered. And those 2 arguments are dispatch, which we can use to dispatch other Redux actions from inside our thunk, and getState, which is a function that we can use to get access to the current state of the Redux store. These 2 arguments are quite useful. In this particular thunk, we're going to be using dispatch as a means to communicate to the rest of our application how the loading process is going. We'll see exactly how this works in a minute. What we're going to do first is open up our actions.js file and create some new actions that have to do with loading to-dos. We'll say export const, and the first action we're going to create is going to be called load to-dos in progress, and it's going to be the string load to-dos in progress. And then we'll create the action creator for this one, which will be very simple. We'll say export const load to-dos in progress, and it won't take any arguments, and it won't have any payload either. It's only going to have the type property. So the type will be load to-dos in progress. So that's our first action. The second action we're going to create will be called load to-dos success. So we'll say export const load to-dos success, and the same thing here, load to-dos success. And the action creator for this one is going to look like this. We'll say export const load to-dos success, and this one is going to take an argument that's the to-dos that were loaded. And the type of this is going to be our load to-dos success type, and the payload will be an object with a to-dos property that contains the to-dos that this action was dispatched with. So we have 2 actions so far. Finally, we're going to create a load to-dos failure action. So we'll say export const load to-dos failure equals load to-dos failure, and then we'll make the action creator for that, load to-dos failure, which won't take any arguments, and it'll simply return an action with the type load_todos failure. So now that we have those 3 actions defined, let's go back to our thunks.js file and use them in our load_todos thunk. So first, what we're going to do is import the actions we created. So we'll say import load_todos in progress, load_todos success, and load_todos failure from our actions file. And as soon as we've done that, what we're going to do here is as soon as our load_todos thunk is triggered, we're going to dispatch the load_todos in progress action. In a little bit, we'll be using this to set an isLoading property in our Redux store to show the rest of the application that the to-do items are in the process of loading. So we're going to say dispatch, using this dispatch argument that we have access to. Dispatch load_todos in progress. And then we're going to actually make the request to our server. So we're going to say const response equals await fetch, and then the URL of our server, which should be running, http://localhost 8080/todos, and then we're going to say const todos equals await response.json. And this is all just the standard logic for making requests to the server. Don't worry if you're not super familiar with it. And finally, once we've loaded our to-dos from the server, we're going to dispatch the load_todos success action that we created. So we'll say dispatch load_todos success with the to-dos that we just loaded from the server. And we're going to use this load_todos success action in a little bit to put all the to-dos that we just loaded into the Redux store. And now that we have all this loading logic, we definitely want to wrap it in a try-catch block so that we can handle the inevitable case where our fetching doesn't work for some reason. So up here, we're going to add try, and we're going to move all of this fetching logic into that block. And then we'll add a catch block that catches the error. And inside the catch block here, what we're going to do is dispatch our load_todos failure action. And just for now, we're also going to dispatch the display alert with the error we just got. And we're going to modify this display alert thunk so that it just displays whatever message we give it. So we just added 3 more actions to our application, and we implemented a load_todos thunk that will handle the logic of loading data from our server, as well as dispatch other actions and thunks depending on what happens during loading. What we've got to do now is write some code that will take these actions that our load_todos thunk is dispatching and make corresponding changes to the Redux store when each of these actions occurs. Now, as you may have guessed, the additions we're going to make to our code will be in the reducers file, so let's open up reducers.js. And the first thing we're going to do here is import the 3 action types we just defined. So let's rearrange this a little bit to make it more readable. And to this list, we're going to add load_todos in progress, load_todos success, and load_todos failure. And now we have to ask ourselves what changes we expect to see in our Redux store whenever each of these actions takes place. And actually, one of the biggest things we're going to want to add to our application, since loading the to-dos from our server takes time, is some sort of loading message that shows in place of our other components only while our data is loading. In order to do this effectively, we're going to want to have something in our Redux store that tells us when our to-dos are loading. Now, there are, of course, many ways to do this, but the way that we're going to do it here, at least for the moment, is by adding another reducer to our file to keep track of whether or not our to-dos are loading. So we're going to define this reducer. We'll say export const, and we're going to call this reducer isLoading. And just like with our to-dos reducer, our isLoading reducer is going to be a function with a state argument, the default value of which will be false, and an action argument. So the job of this reducer will be to either return true or false based on whatever actions occur in our app. In order to do this, just like with our other reducer, we're going to want to say const type equals action, and then use this type to make a switch statement. Switch type. And the three actions we care about here are the three that we just created. So let's code the cases for each of these. We're going to say case load to-dos in progress. And in this case, it'll return true, since when our action gets a load to-dos in progress action, that means we just started loading. And then we'll add a case for our load to-dos success and for our load to-dos failure. And actually, what we return in both of these situations is going to be the same thing. We're going to return false, since those actions signify that the loading has ended in our app. Return false. And last but not least, we have to have a default case that returns whatever the current state of isLoading was before the action was received. Default, return state. So we got our isLoading reducer defined here, but since this is a new reducer, we need to add it to our store.js file just like we did with our to-dos reducer. So open up store.js, and we're going to import this new reducer along with our to-dos reducer, and we're going to add it to this reducers object here. And now our isLoading reducer is hooked up to the Redux store. If we run our application, npm run dev, and look at our app in a browser, we can see using Redux DevTools that our application's state now contains this new isLoading property. It doesn't really do anything quite yet, but it's there at least. So in order to make use of this new reducer, we're going to open up our to-do-list component, and we're going to add brackets around the component definition here and a return statement. This will allow us to have more lines inside of our component. And up here, we're going to say const loading message. And this is going to be an element that we display while our application is loading our to-dos instead of our to-do list. So we'll say div, and we'll just say loading to-dos, ... And then actually what we're going to do is instead of just returning this here, we're going to say const content equals all of this. And finally, down at the bottom of our component, we're going to say return isLoading and use a ternary operator to decide whether or not to show the loading message or the content. So if it's loading, we want to show the loading message. Otherwise, we want to show the content. And the last thing we need to do here is actually get the isLoading state from the reducer. So far, we don't have it in the props up here. So to do that, we're just going to go down to map state to props, and we're going to add a property that's isLoading, and that's simply going to be equal to state.isLoading, the current state of our isLoading reducer. And then let's add it to our props up here. isLoading. And that's it for the isLoading logic. The last thing we have to do is have this to-do list component actually start the loading flow. And to do that, we're going to use React hooks. Don't worry if you're not too experienced with them. They're very simple for this case. We're going to import useEffect from React. And we're going to import our load to-dos thunk. Import load to-dos from thunks. And then up at the top of our component body here, we're going to say useEffect, parentheses, and inside here is going to be a function that's going to kick off our loading to-dos. We'll say start loading to-dos. This is a prop that we're going to need to add through map dispatch to props. And so we'll add that prop up here. Start loading to-dos. And then down in map dispatch to props, we're going to say start loading to-dos. And that's simply going to dispatch our load to-dos thunk. So now if we look at our app, and we might have to refresh it, there's one last thing we have to do that I almost forgot. And to this useEffect hook, we just have to add another argument that's an empty array, which will prevent it from reloading constantly like it's been doing. So let's do that. And now if we go back to our application and take a look at it, it flashes our loading to-dos message very briefly whenever we load our page. If you want to see the loading message for more than just a fraction of a second, the server that I created actually has a to-dos delay endpoint that we can query instead. So if you go to thunks you can add todos delay to the endpoint, and it'll purposely take a few seconds before responding. So that's all there is to it for now. Now that we've defined an isLoading reducer that tells us whether or not our application is in the process of loading our to-dos, we need to make some important changes to our to-dos reducer to reflect the fact that we're now loading data from a server. Currently, the to-dos that are displayed after our app is done loading data from the server aren't actually the to-dos that we get in the response. They're still just our locally defined to-dos. What we're going to do in this video is make it so that our app actually displays the to-dos fetched from the server. So what we're going to do is open up reducers.js, and we're going to incorporate the three actions we created in a previous video, load to-dos in progress, load to-dos success, and load to-dos failure, into our to-dos reducer so that it works nicely with our loading flow. So here's what we're going to do. Down in our to-dos reducer, we're going to create cases for each of our actions like this. We're going to say case load to-dos in progress, case load to-dos success, and case load to-dos failure. And as a matter of fact, for now the behavior of our in progress and failure action types is going to be exactly the same as the default case. And true, we could just leave these cases out, but I'm going to put them here for something that we'll be doing later in the course. So what we're going to do is move this load to-dos success up to the top, and simply remove the bodies of these two so that their functionality is exactly the same as the default case. So now let's look at our load to-dos success case. This case requires a little bit of special treatment. Remember that when we defined our load to-dos success action creator, we said that the payload would be the to-dos array that was loaded from our server. So because of that, what we want to do is when our to-dos reducer encounters the success action, we want it to get the to-dos from the payload, so we'll say const to-dos equals payload. And remember, we're getting the payload from the action up top here. And then what we're going to do is simply return these to-dos as the new state for our reducer. The idea here is that if the user has added or deleted to-dos from the server on another computer, the updated list would simply replace whatever list we had locally. And there are other ways that we might reconcile differing versions between computers, but for the scope of this course, we're just going to do it this way, by saying return to-dos. And now, if we run our app again, npm run dev, and refresh it, we see that it now correctly loads and displays data from the server, which is different than the data that we had before. Currently, our app is loading and displaying server data correctly, but even though it looks like it's creating new to-dos correctly, for example, if we add one up here, when we create a new to-do, the changes only take place locally. Our new to-dos aren't persisted in the server. In this video, we'll see how to make this happen using thunks. So if you remember from an earlier video, and I'm just going to use Postman here for a second to demonstrate something, the way we create a to-do on our server is by sending a post request to the to-dos endpoint with the text for the new to-do as the body of the request. If we send this request, the server will then create this new to-do and return the created to-do as the response to our request. Now, our server will also add a unique ID, a created app property, and an isCompleted property to our to-do for us, so we'll want to be sure to save the to-do that we get back from the server in our Redux store, instead of simply creating it locally when the user clicks the Create New To-Do button in our application. So the first thing we're going to do is define a new thunk that our newTodoForm component can dispatch to kick off the Create To-Do flow, to make that request. So open up thunks.js, and underneath our load to-dos thunk, we're going to create another thunk, and we're going to call it add to-do request. So we'll say export const add to-do request, and it's going to take the text of the new to-do as an argument, and just like our load to-dos thunk, it's going to return an async function that will take dispatch as an argument, which we'll be able to use to trigger other actions from inside this thunk. And then inside the body of the thunk, we're going to create the request body that we'll send to the server, which will just be the text of the new to-do. So we'll say const body equals json.stringify text. And now we're going to use fetch again, but since we want this to be a post request instead of a get request, which is fetch's default method, we need to pass an options object to fetch. And don't worry too much about the details here. It's just going to look like this. We're going to say const response equals await fetch http:// localhost 8080 /todos, and then we're going to pass an object to it, and this object will have a headers property that'll contain a content type property whose value is application/JSON. And then down here, we're going to say method. This will make fetch send a post request instead of a get request. And we're going to include the request body along with this. And now that we have the response up here, which is the new to-do created on the server, what we're going to do is say const to-do equals await response.json. This is just how we do it with fetch. And then we're going to dispatch a create to-do action with the inserted to-do as an argument. We'll say dispatch create to-do with the to-do that we got in the response. And we have to make sure that we import this create to-do action from our actions up here. And then, just like in our load to-dos reducer, we're going to want to wrap all of this logic in a try-catch block. So up here we'll say try, and we'll move this all inside of there. And then we'll create a catch block. And if an error occurs, we'll simply say dispatch display alert with the error, just like we did up here in our load to-dos thunk. And just as a side note, in the real world we'd probably want to do some more elaborate error handling here, but for the sake of example, this serves its purpose. So now that we've got our add to-do request thunk, we need to modify our create to-do action creator and to-dos reducer a little bit so that they work with our new server flow. Here's what I mean by that. Let's open up actions.js. And we just need to change the argument name and payload of our create to-do action creator, like this. It needs to be to-do instead of text. And now if we open up reducers.js and scroll down to the create to-do case in our to-dos reducer, instead of getting the text from the action payload and creating our own to-do, what we're going to do is get the to-do from the payload, const to-do equals payload, and then we're going to simply return this new to-do concatenated to the current state. And that'll look like that. And that's it for our reducer right now. The last thing we have to do is open up our new to-do form component, and we're going to make it dispatch the thunk we just created instead of the create to-do action creator. So we're going to delete this line here. We're going to say import add to-do request from thunks. And down here in onCreatePressed, we're going to replace create to-do with add to-do request and pass it the text. And that's it. If we restart our application and take a look at it again, we see that it should work quite nicely when we try and add new to-dos. In other words, it'll actually add them to the server. And if we refresh it now, we see that it stays, which didn't happen before. So far, we have a thunk for loading to-dos from the server and a thunk for creating new to-dos on the server. So one of the next logical steps for us is to add a thunk for deleting to-dos from the server, so that when the user clicks the remove button on one of our to-dos, it actually persists those changes. The process for adding this logic to our application is going to be very similar to the previous video where we created new to-dos. The main difference here is our interaction with the server endpoint. Instead of sending a post request with a payload, like we did in our add to-do request thunk, we're going to be sending a delete request to todos/id, and as a response, the server will be sending the to-do that just got deleted, which we'll have to use in our to-dos reducer to remove that to-do locally. So let's open up our thunks.js and add a new thunk called remove to-do request. We'll say export const remove to-do request equals, And we're going to use ID as an argument since the server is now giving us back unique IDs. And this thunk, just like all the others, will return an async function that takes dispatch as an argument. And then inside our thunk, we're going to have a try-catch block. In our catch block, we'll just do dispatch display alert, just like we did before. And then what we're going to do, again, this is going to be very similar to our other thunks. We're going to say const response equals await fetch. And we're going to use backticks here since we'll want to put the ID into the URL we're sending a request to. We're going to say http://localhost 8080/todos/ and then we'll use string interpolation to insert the ID into here. And for this request too, we're going to have to specify the method. This is going to be a delete request instead of a post or get request. And then we're going to get the removed to do from the response by saying const removed to do equals await response.json. And finally, we're going to say dispatch remove to do with our removed to do as the argument. And this won't work yet because we still haven't changed the action creator and reducer. So let's open up actions.js. And we're going to change the remove to do action creator like this. Instead of text, we're going to say to do, and the payload is going to be to do instead of text as well. And then if we open up reducers.js and scroll down to the remove to do case in our to-dos reducer, what we want to do is, instead of getting text from the payload, we're going to get to do from the payload. And we're going to nickname this to do to remove. And instead of filtering based on the text of our to-dos, as we were doing before, we're going to filter based on ID. So we're going to say todo.id does not equal to do to remove.id. This will filter out the to-do that just got removed from the server. And last but not least, we have to make sure our to-do list component dispatches the thunk we just created instead of the remove to-do action. So we're going to open up to-do list, and we're going to import our new thunk. We're going to say remove to-do request, and we can delete this remove to-do from the actions. And down here in map dispatch to props, we're going to say remove to do request, and we're going to have to change this from the text to the ID of the to-do item. So just one last thing, we have to go in todoListItem, and instead of saying todo.text, we're going to have to say todo.id. And just one last thing that I'm remembering before our app will actually work, we have to go into thunks, and down here where it says dispatch remove to do, we have to actually import remove to do from our actions. And then we'll clean this up a little. And now if we run our app, it should work like we want it to. So let's run it and open it up. And now if we click remove on any of these, it should remove it permanently, which is just our thunks at work. Okay, so we've already seen how to use thunks to create, read, and delete resources on the server. The final step is to create a thunk that allows us to update resources on the server. Your challenge in this video is to implement the flow for marking to-dos as completed. This will build off the work you did in the previous challenge, where you created the action and reducer logic for marking to-dos as completed, as well as dispatch this action when the mark is completed button was clicked. So before you start this challenge, there are a couple things to keep in mind. The first is about the request. You're going to want to send a post request to todos/id/completed. And keep in mind also that this endpoint will give you back the entire updated to-do as the response. The second thing to keep in mind is that just like in the previous videos, you'll almost definitely need to make some changes to the action creator and reducer in order to make this work correctly, as well as update the components to use your thunk instead of the old action. This challenge should probably take you about 10 to 15 minutes to complete. After you've given it a try, Feel free to move on to the next video where I show you how I solved this challenge. Okay, so let's take a look at one possible solution to marking a to-do as completed on the server using thunks. The way I started off was by opening up thunks.js and adding a new thunk called mark to-do as complete request. Export const mark to-do as completed request. And this thunk took an ID as an argument and returned an async function that took dispatch as an argument, the same as the rest of our thunks. And for the body of this thunk, I pretty much just copied and pasted the body from the remove to-do request thunk. The main changes I made here was first of all to change the URL that we're sending a request to by adding /completed to the end of it. And then for the method, instead of sending a delete request, I sent a post request. And then I renamed this from removed to do to updated to do. And finally, the action I dispatched was mark to do as completed with the updated to do that we got back from the server. And I had to import that action up at the top. So with my thunk created, the next thing I did was move over to actions.js and make changes to the mark to do as completed action creator. Just like with the transformations we did when creating our other thunks, the first thing I did was change the argument from text to to-do and change the payload as well. And then I went over to reducers.js and modified the mark to do as completed case. So instead of getting text from the payload, which is no longer there, I got to-do from the payload and nicknamed it updated to-do. I then left this state.map statement, but what I did instead of setting isCompleted true on one of the to-dos was if a given to-do's ID was equal to the updated to-do's ID, I simply replaced it with the updated to-do. So that's all for the basic plumbing. The next thing I did was go to todoList.js. And instead of using the mark to do as completed action in this component, I imported the mark to do as completed request from the thunks and used that down here instead. And then just like we had to do when removing a to-do item, I had to change this argument to ID and change this to ID as well. And then since it's getting passed through to todoListItem, I opened up todoListItem and made this change as well. Instead of calling onCompletePressed, which is now our thunk, with the text of the to-do, I called it with todo.id, just like we did when removing to-dos. And that should do it for the changes. If we run the app at this point with npm run dev and open it up in a browser, whenever we click mark as completed for a given to-do item and refresh the page, it should stay that way, even when we refresh it. Well, that was my solution anyway. Congratulations if you figured it out for yourself. In a previous section, we saw how to add Redux to a React application, as well as how to connect our components to it so that they could get access to the data in the Redux store and dispatch Redux actions. And this relieved our components of the need to manage their own state, as well as made it much easier to share state between our components. We also saw how to use thunks to remove side effect logic from our components. So a main theme so far with our React ecosystem tools has been the separation of concerns. We want our components to worry about displaying the data we give them, we want our reducers to worry about making changes to the state, and we want our thunks to handle all of the side effects logic and server communication. And so far we've done a pretty good job of ensuring the separation of concerns, but there are still one or two things that are a little bothersome, and they might not be obvious at first. Let's take a look at the map state to props function for our components, and specifically how it's getting the data from the state by referring exactly to how certain data is stored in the state. At first glance, this might seem pretty harmless, and most of the time it is, but here's the problem. Getting the data we need from the state in this way requires our components, and more specifically our map state to props function, to have an intimate knowledge of how our data is stored in the state. Now this might not quite make sense with the way the state is set up right now, but to show you an example, let's imagine something for a minute. Let's imagine that instead of storing our to-do data directly in state.todos and our isLoading data in state.isLoading, as we've been doing, we want to incorporate the isLoading property into the todos reducer and move the actual todos data into state.todos.data. This is something that we can absolutely do, and I've seen it done in many React applications. But the problem here comes up if we have multiple components that we're all referencing state.todos and state.isLoading directly, because now we have to go through and change all of them to reflect our changes to how our data is stored. What we could do instead is, rather than referring directly to state.todos.data or state.todos.loading or whatever it is that we're trying to pull out of the state, we create some simple functions called getTodos and getTodosLoading, and we use these functions in the map state to props for all our components. If we had created and used these functions from the start, incorporating the isLoading property into our todos reducer and moving the actual todos array into todos.data, or making any other modifications to how our data is stored in the state for that matter, all of this would be a simple one-line change. So at first it might seem a little silly to go through the trouble of creating separate functions just to avoid difficulties when doing something simple like changing state.todos to state.todos.data. After all, that would be easy enough to do just by doing a global find and replace in our project. But actually, selectors are part of something bigger. Here's what I mean. Oftentimes we want to pass our components data that requires a little bit of computation to obtain. For example, if we had separate to-do lists for the to-dos that were completed and to-dos that were incomplete, this would require either our components or our map state to props to include filtering logic, neither of which is ideal since it adds unnecessary complexity to our component files. And this all is another reason that selectors exist, to give us a place to put the logic for transforming data in the store into data our components can use. In the case I just described, we could simply have selectors called getCompletedTodos and getIncompleteTodos, each of which contains the logic necessary for filtering all the to-dos in the Redux store into specific sublists. And then we could use these selectors in our map state to props instead of putting the actual logic itself there. We'll look into this in more detail in coming videos. So now we know the basics of why we need selectors in a React-Redux application, and the basics of what a selector is. In this video, we're going to create our first selectors and incorporate them into our application. We saw previously that selectors are meant to abstract away how data is stored in Redux, as well as give us a place to put logic for transforming Redux data into data that our components can use. We're going to start off by looking at the first purpose, abstracting away how our data is stored in Redux. If we open up our todoList component, we can see that in the map state to props function, we're referring directly to how our data is stored. What we're going to do is take these two things, state.todos and state.isLoading, and create selectors for them. So inside our todos directory, let's create a new file called selectors.js. And then inside this file, we're going to create a function called getTodos. So we'll say const getTodos, and it'll take state as an argument, and return the location in our state that our to-dos are stored. So it'll just say state.todos. And likewise, we're going to do the same thing with isLoading. We'll say const getTodosLoading state, and we'll say state.isLoading. And then we'll export these two selectors so that we can use them elsewhere. So the next thing we're going to do is bring these selectors into our todoList component. So let's open up our todoList component again. And up at the top, we're going to import the selectors we just created. So we'll say import getTodos and getTodosLoading from selectors. And the way we're going to use these is down in map state to props, instead of referring directly to state.isLoading or state.todos, we're going to replace these references with the selectors we just created. So for isLoading, we'll say getTodosLoading and call it with state. And likewise for todos, we'll say getTodos and call it with the state. And since we connected our newTodo form as well, and it's using state.todos, we're going to import our getTodos selector, import get todos from selectors. And we're going to replace this reference to state.todos with get todos from state. And if we run our app and look at it again, npm run dev, we should see that our app works exactly the same as before, except now it's using selectors instead of just referring directly to how data is stored in the state. So now that we have our selectors created and incorporated into our application, let's take a look at how this allows us to modify the structure of our data in the Redux store without disturbing our components whatsoever. Previously, I mentioned that one of the things we might want to change about our Redux store is to incorporate our isLoading reducer into our todos reducer. This would make it more self-explanatory, for example, if we had other resources, such as users, that we needed to load from a server as well. This would require us to have another isLoading reducer for loading users, or whatever other resources we needed to have a loading indicator for. So what we're going to do then is have a single todos reducer, which stores the current todos array in the Redux store, as well as whether or not the app is currently loading todos. And in order to make this happen, we're going to store the todos array in state.todos.data, which is going to be our todos, and we're going to store the loading state in state.todos.isLoading. So what this means is that we have to combine our isLoading and todos reducers like this. I'll show you how. First of all, the initial state that we're going to start off with, we'll define a separate constant for that. We'll say const initial state equals, and it's going to have isLoading, and that'll initially be false, and data, and that will initially be an empty array. And then we're going to set the default value of state to this initial state. So now we're going to go through each of the cases in our switch block here and replace it with the appropriate logic. So for create todo, we're still going to get the todo from the payload, but instead of simply returning state.concat, what we're going to do is use the spread operator to get the rest of the state untouched. And then for data, we're going to say state.data.concat with the new todo item. And moving on to remove todo, we're still going to keep this todo to remove statement here, but instead of simply returning state.filter, we're going to return and use the spread operator to get the rest of the state, and then for data, we're going to say state.data.filter, and that's all we need to do for that. Now moving on to mark todo is completed, we're going to leave this untouched, and instead of simply returning state.map, we're going to add ... state using the spread operator again. And then for data, we're going to say state.data.map. And we're going to indent this a little more. And that's it for mark todo is completed. So now when we get down to our load todos success, load todos in progress, and load todos failure, only now do we have to start worrying about our isLoading reducer up top, since these cases are shared in this one. So for load todos success, for example, what we're going to do is instead of returning just todos, we're going to use the spread operator to get the rest of the state, and then inside here we're going to say isLoading and set that to false, and then we're going to set the data in the state to the todos that we just loaded successfully. And if we move down to load todos in progress, what we're going to do here is add a return statement that says spread operator state, and we're going to set isLoading to true here. And finally, for load todos failure, we're going to say return ... state isLoading false. So that's definitely a bit long-winded there, but now what happens is we can remove this isLoading reducer completely, and we have to go to store and remove it from here as well. And if we run our app now, it's going to break because our selectors are expecting the wrong data format in our Redux store. Now, the beauty of selectors, however, is that all we have to do now is change these two functions. So for getTodos, instead of saying state.todos, we'll say state.todos.data. And instead of state.isLoading, we'll say state.todos.isLoading. And now if we refresh our app, it'll work perfectly again, even though we only made those 2 changes after that huge refactor of our reducer. Previously, we saw that selectors can help our components be independent of the exact structure of data in our Redux store. Now it's time to take a look at their second purpose, to give us a place to put the logic necessary for transforming bare Redux data into more specific data that our components might need. In order to make this example more effective, let's say that we're going to make a change to our application. Instead of having a single to-do list that displays all of our to-dos, let's say that we're going to change our application so that we have 2 separate lists, one to display the completed to-dos and one to display the to-dos that we haven't completed yet. Now, this change requires us to perform a little bit of logic to transform the data contained in our Redux store, which simply contains a list of all our to-do items, into lists of our completed or incomplete to-dos. Now, our first instinct with this situation might be to perform this logic inside our mapStateToProps function. But now that we know about selectors, we can imagine that selectors might be a better place to put this kind of logic. So we're going to go back to our selectors.js file and create some new selectors. The first one will be called getIncompleteTodos, export const, getIncompleteTodos, and we're going to stop here for a minute. Before we go on, there's another ecosystem tool we're going to add to our project. When we need to create selectors that make use of other selectors, for example, our getIncompleteTodos selector will need to use our getTodos selector, there's a tool called Reselect that we can use to build more complex logic on top of simpler selectors, and even combine different selectors if need be. So let's start off by installing the Reselect library into our project by opening up a terminal in your project and typing npm install reselect. And once that completes, we're ready to see what Reselect can do. So let's go back to our selectors.js file and implement this getIncompleteTodos selector that we need for our app. I'm just going to implement it first using Reselect, and then afterward I'll explain it in more detail. So using Reselect to create a selector looks like this. We start off by importing something called createSelector from Reselect. Import createSelector from Reselect. And then we'll implement our getIncompleteTodos selector by saying something like this. Equals createSelector. And we pass our getTodos selector as an argument. And for the last argument, we're going to define a function that takes todos as an argument and says todos.filter and gets only the to-dos that are not completed from this array. Not todo.isCompleted. So that's what a Reselect selector looks like. So how does it work exactly? Well, as you can see, we're using this createSelector function, and basically this function takes a variable number of arguments, each of which is some sort of selector, and the last argument that we pass to it is a function whose return value is the return value of the entire selector. So in this case, calling getIncompleteTodos with state as an argument, from inside a mapStateToProps, for example, we'd do this. This would return all the to-dos in the state whose isCompleted property was false. Now, the really interesting part of this createSelector function is that we can pass as many selectors as we want here, and the last function that we pass to createSelector will get the result of all the other selectors before it. So just as an example, if we not only needed the to-dos from our Redux store, which we're getting using our getTodos selector here, but we also needed to know whether or not our to-dos were loading, we could add our getTodos loading selector as an argument like this, and then the return value of that selector would get passed to our final function as a second argument. So if we wanted to use this isLoading argument to modify the return value of getIncompleteTodos, for example, if for some reason we wanted to return an empty array whenever the to-dos were loading, we could do that here like this. We'd say isLoading, and then use a ternary operator to return an empty array if it is loading, and otherwise we return the incomplete to-dos. And I'm just going to delete this because this is not what we want for our application right now. So in theory, we can add as many other selectors as we want to this function. Now granted, we've only seen it with 2, but you get the point. And the cool part is that we're not only limited to passing simple selectors such as getToDos or getToDos loading to create selector, but we can also pass in other selectors that we've created with create selector. And this allows us to build up an ever more expressive library of selectors that our components can use to transform the data in our Redux store into a format that they can use. So now that we've created our getIncompleteToDos selector, let's create another selector that will give us all of our completed to-dos. And this is going to be very similar to our incomplete selector. We're going to say export const, and we'll say getCompletedToDos equals create selector, with the arguments getToDos, and the final function here is going to simply take the to-dos from the state and say todos.filter, and then it's going to get all of our completed to-dos by saying todo.isCompleted. And that's really all we need to do. But before we move on and incorporate these selectors into our components, there are 2 things I'd like to note about these kind of selectors. The first thing you should notice is that just like our components, these higher order selectors that we've defined, our incomplete and completed to-dos, have no idea how our data is formatted in the Redux store. Nowhere here are we referring to state.todos.data or state.todos.isLoading. So even our higher order selectors rely on our lower level selectors, such as getToDos, to worry about the exact format of our data in Redux. So while it might have seemed a little silly beforehand to define a super simple function like getToDos or getTodosLoading, in the long run it really helps us out. And that's because now, as the number of selectors grows, we won't be referring directly to state.blah blah blah in any of our higher order selectors. So if at some point we need to change the way our data is formatted in Redux, from the point of view of our selectors, it'll essentially be a one-line change. So that's the first thing to note about our selectors. The second thing is that the selectors we create with Reselect's createSelector function use something called memoization. So what on earth is memoization? Well, to put it simply, let's say that we have a function whose output is determined solely by its input. In functional programming, we call these pure functions, and all our selectors so far are good examples of this. Now, if we call a pure function twice in a row with the exact same arguments, it'll give us the exact same result. And because of this fact, if we were to run our entire function again the second time we call it, we'd be completely wasting computational power, since we could have just saved the result the last time this function was called and returned that pre-computed result when we saw the same arguments were getting passed in. So with that all in mind, take a look at our getCompletedToDos and getIncompleteToDos functions. The only thing that will change their output is the todos.data array in the Redux store. Now granted, at the moment our entire store is still pretty small, but in a full-sized React-Redux application, our todos array would likely only be a tiny part of our entire Redux store, so it wouldn't make sense to recompute the completed and incomplete to-dos every single time our components re-rendered. So that's one of the nice things that this createSelector function does for us. It makes sure that the parts of the state that it cares about have actually changed before completely recomputing the result it returns. And this is a somewhat important point to understand, because on the surface, it might seem like createSelector doesn't really do anything. In other words, it seems like we could replace our getCompletedToDos here, for example, with a function that looks like this. We could say export const getCompletedToDos equals state, and just have a regular function that says const data todos equals state.todos, and then say return todos.filter todo.isCompleted. On the surface, it looks like using createSelector does exactly the same thing as what we defined here, but it doesn't. If we had just defined getCompletedToDos like this, it would recompute every time our app re-rendered, even if the input and output of this function was exactly the same. When we use createSelector, the return value of this function only changes when the return value of the selectors that we pass as arguments changes. So anyway, that's just something to keep in mind when working with Reselect. Okay, so now that we've created some more advanced selectors using the Reselect library, let's incorporate these selectors into our components. Now, if you'll remember, what we want to do is split our to-do list into two separate lists, one that contains the completed to-dos and the other that contains the to-dos that we haven't completed yet. And as a matter of fact, now that we've created these two new selectors here, get completed to-dos and get incomplete to-dos, this is actually quite easy. So what we're going to do is open up to-do list, and the first thing we're going to do is import the two selectors we just created. So up top here, we'll add get completed to-dos and get incomplete to-dos. And once we've done that, we're going to go down to our map state to props function, and instead of having a single property called to-dos that we pass to our component, we're going to split this into two props, one called completed to-dos and the other called incomplete to-dos, and we're going to use the corresponding selector for each of these. So that'll look like this. Completed to-dos, get completed to-dos from the state, and incomplete to-dos, we're going to get the incomplete to-dos from the state. And now that we've done that, up at the top we're going to add these new props to our component. So we don't need to-dos anymore, but we do need completed to-dos and incomplete to-dos. So that's easy enough so far. The last thing we're going to do is, instead of having just one list down here, we're going to map both arrays of to-dos, our incompleted and completed to-dos, each with their own heading. So that's going to look like this. We'll say H3, incomplete, and we're going to say incomplete to-dos.map. And then down here, we'll say H3, completed, and we'll copy and paste this and change this to completed to-dos. And if we run our app again, npm run dev, and take another look at our app in the browser, we should see that the changes we wanted are there and that they seem to work really well. And that's the power of selectors at work. So far, we've done a very good job of separating out most of the logic from our components. We have Redux to manage our application state, Thunk to manage our side effects, and selectors to make it so that our components don't have to know how our state is set up or contain any logic for transforming the data we get from the state. So we're very close to having components that are truly free of all logic that doesn't belong. We're going to take one more step toward this goal of separation of concerns, and that's by adding something called styled components to our project to make it a little easier to, well, as you may have guessed by the name, style our components. Currently, our app is using CSS modules in order to style how our components look. And this is an extremely common practice, but in my opinion, using CSS modules with React falls a little short of ideal. First of all, having an extra CSS file for every component really clutters up the directory structure. But there's another bigger concern here as well. Let's take a look at an example. Let's say that in some application we have a list of items, and that at any time, one of these components can be selected. Now, if we're using CSS modules to do our styling, what we have to do is set the class on our list items dynamically, depending on whether or not a given list item is selected. And to me, this just sort of feels like an unnecessary intermediate step. It doesn't seem like this kind of logic should be directly inside our components. And things get worse when we want to make some more precise changes to the styling of our components. For example, if we were to have a list of bank accounts, and we want the background color of the list items to reflect the balance in that account. For example, we want it to go gradually from red to yellow to green, depending on how much money is in a given account. And these are things that styled components can help us with. Granted, there are other ways to do this as well without using styled components, but I've found that the way that styled components handles this is really my favorite way. So what are styled components exactly? Styled components are what's referred to as CSS in JavaScript, and what they allow us to do is define styling for our components inside of our JavaScript files. Now this has some pretty cool implications. For example, it allows us to define our own UI components that we can pass props to. In the case of styling a selected list item, for example, instead of having to swap styles inside our component, we could just pass a selected prop and use this prop inside our styling to decide what the background color of our element should be. And for our bank account example, we could just pass in a balance prop and use that prop inside our styling to calculate what the correct color should be. And the nice part about this is that it moves all the styling logic out of our main component and into a part of our code whose sole job it is to handle that kind of logic. We'll see exactly how to do this in the videos that follow. Now that we know what styled components are and some of the situations where they can help us, let's install the styled components package and add our first styled component to our app. So the first thing we're going to do is install styled components into our project. So let's open up a terminal inside our project directory, and we're going to run npm install styled-components. And once we've done that, we're free to use styled components in our project. So let's start off by doing a little styling on our to-do list. So let's open up our to-do list component. And at the top, we're going to say import styled from styled components. And let's delete this unused import here since we won't need it anymore. And then down here, right above where we define our to-do list component, we're going to create our first styled component. And here's how we create a styled component. We're just going to create a dummy component for now as a proof of concept. We'll say something like const big red text equals styled.div, and then a pair of backticks. And inside those backticks, we'll say something like font size 48 pix, and color we'll do bright red, which is FF0000. And I'll talk about this syntax a little more in a minute. It might look strange to some of you. So once we've created a styled component like our big red text here, we can add it to our page just like any other React component by doing something like this. Down here, inside our list wrapper, we're going to say big red text, and then inside that we'll put the text, I'm a styled component. And if we run our app now with npm run dev, and take a look at our app, we see that our big red text styled component is displayed exactly as we wanted with the styling we defined. So that's the basics behind how styled components work. Let's go back to the syntax of how to define a styled component. So we can see here that the styling is defined using this backtick syntax. And you may or may not have ever seen this before, but it's actually something called a tag function. And I'm not really going to go into the details of how tag functions work. For now, all you need to know is that it's what we use to define styled components. Now, the other thing to note about styled components is that while we've used styled.div here to define our big red text, we could have also used styled.h1 or styled.button, or pretty much any other standard HTML element as the basis for our styled component we're defining. We'll see some more examples of this later on. And last but not least, there's the question of where to put our styled components. Do we put them in the file alongside our components as we've done here? Or do we create a separate styled.js file to hold them? Well, that's really up to you. What I usually do is keep them in the same file as my components until I have several and feel like they're starting to clutter up the files, at which point I create a separate file to hold my styled components. Now, the exception here, of course, is with more general, site-wide components such as buttons, modals, or forms, where the components are widely used and applying similar styles to them all over the site would be a waste of time and code. In that case, I like to create a user interface folder in my project and store the styled components for those commonly used items there. But at the end of the day, this is one of those things where you should really just play around with the organization and see what works for you. So let's just delete this big red text component for now, since that was just an example. Alright, we know the basic syntax for defining and using styled components, so now it's time to convert all of the styling in our app, specifically in our CSS modules, over to styled components. Now, this is obviously a bit of a tedious task, so it might take a little while, But just bear with me here while I walk through converting each of our components to a styled component. So the process for this is fairly straightforward. We're going to open up each of our CSS modules here, and for each of the stylings that we've defined, we're going to create a styled component for it and replace that inside the corresponding component. So we're going to start off with our to-do list here. We're going to start off with todolist.css, and this one is fairly simple since it only contains one styling here. So what we're going to do is simply copy and paste these two styles here, and then go into to-do list, and make sure our styled is imported from styled components. It's still here from the last video. And down here, right above where we define our to-do list component, we're going to say const, and we'll call it list wrapper, equals styled.div, since the component that we're going to be styling is a div. And then inside the backticks here, we're going to simply paste those styles that we copied from our CSS. And now that we have our list wrapper styled component, we're simply going to go down here and replace this div with the class name with our new list wrapper styled component. And we'll do that down at the bottom as well. List wrapper. And now that we're using styled components to do the styling instead of CSS modules, we can simply delete this import statement here. And we can also delete the CSS file itself. So let's run our project just to make sure everything looks the way it should. And everything still looks in order. So we'll move on to our todoListItem component. Now, if we open up the CSS for our todoListItem, we see that there's definitely more styling here than in our todoList component. But nevertheless, the process is pretty much the same. We'll start off with the todoItem container, and then open up our todoListItem, and import styled from styled components. And then up here, above where we define our todoListItem component, we're going to say const todoItem container, which remember is the style that we're replacing here, equals styled.div, and then we'll paste the styling in there again. And then we're going to replace this element here with our todoItem container, and we'll replace it at the bottom as well. And then we'll do the same thing with our buttons container. We'll say const buttons container equals styled.div, and paste the styling. And then we'll replace that element here. Buttons container. And then for the two buttons on our todoListItem, what we're going to have to do for now, and I'll show you a different way to do this in a minute, but what we're going to do for now is simply duplicate this styling between both our completed button and our remove button. And again, we'll see another way around this in a minute. So for now, we'll say const completed button equals styled.button. And we're going to paste our basic button styling, as well as the specific styling for just our completed button. And we're going to do the same thing with the remove button. We're going to copy this styling here and create another styled component, const remove button equals styled.button, paste the basic button styling, and paste the styling specific to the remove button. And then we're going to replace this button element with the completed button, and replace this one with the remove button. And we need to make sure to get the closing tags as well. And that's it for our todoListItem. If we go back here and refresh it, we see that everything looks just the same as before. So now we'll move on to our new to-do form. We're going to open up our component, add styled components at the top, import styled from styled components, and start with the new to-do form styled component. So we'll say const new to-do form. And actually for this one, we have to change the name a little bit since new to-do form is the name of our actual component. So in this case, what I usually do is just call it something like form container. And then we'll say equals styled.div backticks and paste the styling in there. And then just like with the other ones, we're going to replace this element with form container. And we're going to replace it at the bottom as well. Form container. And we're going to move on to new to do input. We're going to copy that styling. And we're going to create another styled component called new to do input equals styled.input. Paste that styling and replace the element with new to do input. And then do the same with the new to do button. So we'll say const new to do button equals styled.button and paste the styling. It's pretty tedious, isn't it? But once we have this, it'll allow us to do a lot of cool things, so I promise it'll be worth it. So now that we've got that done, we can delete the CSS module from the top here, and do the same thing with our to-do list item, which I just remembered. And we're going to delete this CSS, delete the new to-do form CSS, make sure everything still looks good, and it looks like this isn't working because of a typo I made, so let's go back and correct that. If we just change this back and save it, we should see that it's almost back to normal. And I actually forgot to add this new to-do button, which happens sometimes. So we'll change this from button to new to-do button. And change the closing tag as well. And we can delete this class name here. We can delete this one as well. And once we've done that, we see that everything is back to the way it was before. So that's been pretty tedious, and there's just one more thing we have to do. That's to use styled components on our app component. So up at the top here, let's just do this one last thing. Import styled from styled components. Copy the styling. Say const app container equals styled.div. Paste the styling. And replace this with app container. App container. And that should be about it. We can now delete the CSS. And our app still looks just as good as it did before, but now it's using exclusively styled components. Okay, now that we have all our styling converted over to styled components, you may be wondering what the point of all of that was. It didn't really reduce the amount of styling in our app, and it also didn't make our app look any different. Well, in this video, we're going to learn about a feature of styled components that, in my opinion, makes the initial work of incorporating them into our app completely worth it. Since you're most likely very familiar with React by this point, you'll know that one of the main features of React is that we can pass props to components in order to configure them in some way. For our to-do list items, for example, we pass in data that specifies the to-do that should be displayed in that particular component. Well, one of the really nice things about styled components is that we can pass props to them as well and use those props to modify their styling and provide better visual cues for the user, depending on the information we're displaying. So to show you what I mean, let's make some changes to the appearance of our to-do list items. You might remember from a previous video that the to-do list items that the server gives back to us, in addition to having a text property and an isCompleted property, also have a created@at property that tell us when that particular to-do was created. So since we have access to the date that a given to-do was created, why don't we display to-do items that are older than a few days with a red outline or something like that, so that the user sees them as more urgent? Well, the first thing that we'll probably want to do is display the actual created@at date on each of our to-do items, and we'll do that like this. Right underneath the to-do text, we'll say paragraph, and then we'll say created@, and then a non-breaking space. And then we're going to do a little bit of code wrangling here to get this date to display correctly. We're going to say, in parentheses, new date, todo.created@, and then we'll say dot toLocale date string with parentheses after it. And if we run our code, just to check that this works, we should see that our app now displays the created@at dates for all of our to-dos. And keep in mind that the way I created the fake to-dos on the server was simply by taking today's date and subtracting a certain number of weeks. So that's where these dates came from. They might be different from the ones you have. So now that we've done that, let's apply custom styling to older to-do items that should be displayed as more urgent. So here's how we do that. For this to-do item container component that we defined, we're going to want to pass the created@at date into this component as a prop. So we'll say created@, equals, and then we're going to pass todo.created@. And now that we've done that, here's how we can use this created@at prop inside our style component. Let's go up to where we defined our to-do item container, and what we're going to do is add a border bottom property to the styling. What we're going to be doing here, again, is adding a red border to the bottom of any older to-do items. And once we've done that, we're going to use this styled component's props to decide what the value of this property should be. And to do that, we'll use string interpolation like this, $, brackets. And then inside this interpolation, we're going to create a function that takes one argument called props and returns the value we want for the bottom border. So what we're going to do is say new date props.created@, is greater than new date date.now minus 8,640,000, and this is equal to 1 day in milliseconds. So let's say times 5. So what we're saying here, if you didn't quite pick up on it, is if the created@at date of a given to-do is more recent than today's date minus 5 days, and then we're going to use a ternary operator here to decide what the actual value of border bottom should be. So if it's a more recent to-do, we're going to display no border. And if it's an older to-do, we're going to say 2 pics, solid red, at the bottom. And don't forget to add a semicolon. And I'm realizing right now that this prop that we're passing in doesn't quite match the name. It should be created@at instead of create@. So if we correct that and save our app, and go back and look, we should see that our older to-do items now have this nice red border along the bottom to make them look more urgent. And again, the nice part about this is instead of having to include the logic down here in our JSX for deciding between different stylings, the logic's now pulled up into our styled components where it belongs. And this has the potential to really clean up our JSX even more. In a previous video, we added props to our to-do item container styled component to make it display differently depending on whether or not a to-do was older than a certain number of days. But here's the thing. Currently we're displaying it on all of our to-dos, the incomplete and the completed. Wouldn't it make more sense to only show that custom styling on the incomplete to-dos? Well, there are really 2 main ways to do that. One way would be to pass in another completed prop to our to-do item container styled component and use that as an extra condition for applying the red border. And that way's perfectly fine to use, but the other way is the way that I'm going to show you how to use in this video. So before we added this red border logic to our to-do item container styled component, it was just a typical styled component with no special functionality. Now, one way we could go about adding the red border logic only to incomplete to-do items, the naive way that is, would be to simply copy and paste the styling and only have that logic in one of them. So in other words, we'd copy and paste all of this styling here and create a completed to-do-item container without this border bottom property. Now, obviously, this isn't really a good way to do things, since if we wanted to change the appearance of our to-do list items while still keeping them consistent, we'd have to make the exact same changes to both, which is a complete slap in the face to the idea of code reuse. So what we can actually do instead is extend our styled components in a similar way to how we can extend classes in object-oriented programming. Here's how we do that in this situation. What we're going to do is cut out this border bottom styling from our to-do-item container styled component, and we're going to create another styled component called to-do-item container with warning. And then instead of the regular styled.div syntax, what we're going to do is say styled and wrap our to-do-item container. And then we'll use the exact same backtick syntax and paste our border bottom styling into it. And this basically means that this new styled component we're defining will start off with all the styles from to-do-item container. And then it'll apply whatever styles we add here over the top of those existing styles. So once we've defined this to-do-item container with warning styled component, which admittedly is kind of a long name, we're going to go down into our component. And inside of here, we're going to make it a more extensive body with a return statement instead of simply an arrow function. And then what we're going to do is above this return statement, we're going to say const container equals, and then we'll say to-do.isCompleted, and then we'll use a ternary operator to decide between whether we use a to-do-item container or our new to-do-item container with warning styled component. So if it's completed, we want to use the regular to-do-item container. Otherwise, we want it to be to-do-item container with warning. And then here, instead of saying to-do-item container, we simply say container for what we defined up here, and container again. And now if we run our application, npm run dev, and refresh, we see that now the warning styling is only applied to incomplete to-do items. So that right there is just one example of extending styled components. Another place that we can do this, if you remember from earlier in the course, is with our buttons. Right now, both our completed button and our remove button share a good part of their styling. So what we can do is simply define a styled component called button, const button equals styled.button, and copy this shared styling into there. And then from both our completed button and our remove button, we can delete all this logic and simply extend the button styled component that we just created. Styled button. And we delete all this redundant styling and save it. And if we go back to our application, we see that it's exactly the same as it was before. So far in this course, we've learned about several very important tools in the React ecosystem that we can use to make the task of building large, complex React applications much easier. However, the one thing we've failed to discuss so far, that may have occurred to people for whom testing is an important part of the development workflow, is how do we go about testing each of these tools in an effective way? Well, fortunately, it's not only possible to test the main ecosystem tools, in most cases it's pretty easy to do so. In the videos that follow, we'll see how to test reducers, thunks, selectors, and styled components. We won't be covering how to test the React components themselves, since that's really a huge topic and honestly could take up an entire section or course on its own. And we also won't be testing actions, since in the way that we've written them without any kind of logic whatsoever, they really don't require much testing. So before we move on to seeing how to test each individual tool, we're going to install two libraries that we'll use to run our tests, Mocha and Chai. These are two of the most common JavaScript testing libraries, and they're both super easy to use, so don't worry if you haven't encountered them before. So to install the libraries, we're going to run npm install --save dev mocha and chai. And once we've done that, it's also important to install another package, npm install save dev at babel/register, so that our tests can run modern Babel code. And once we've installed all those things, inside our source to-dos directory, we're going to create a folder called tests. And this is where we're going to put the tests for our different ecosystem pieces. Now, the way that we're going to run our tests once we've created them is by using an npm script. So let's open up package.json. And inside the scripts section, we're going to remove the pre-existing test script, since it doesn't do anything, and then add the following line. We're going to remove this and say mocha \, quotation mark, source /***.test.js \, quotation marks, and then -- require at babel/register -- recursive. So that's a pretty long command, which is exactly why we created an npm script for it. But now if we save this package.json file and run npm run test, we should get an error saying that no test files were found. And that's because, quite simply, we haven't created any test files yet. So let's move on to writing tests for the different pieces of our ecosystem. The first ecosystem tool we're going to look at testing is Redux. Testing reducers is very important in a React-Redux application. They control the central state of our app, so it's pretty vital for them to work correctly under all normal circumstances. The good news is that testing reducers is actually quite easy. Reducers are pure functions, which means that they have no internal state for us to set up. We simply have to define a current state and an action and pass those two arguments to our reducer to see if it returns what we expected it to. So let's walk through an example to show you exactly what I'm talking about here. We're going to write a test for our to-dos reducer. So the first thing we're going to do is inside this tests folder, let's make a new file called reducers.test.js, and we need to name it .test.js so that Mocha will find it with the command we're running. And then inside this file, we're going to import chai's expect, which we can use to make assertions. Import expect from chai. And then we're going to import our to-dos reducer so that we can test it. We'll say import to-dos from /reducers. And once we do that, let's create a describe block that will contain the tests for our to-dos reducer. And for those of you who aren't familiar with Mocha, this is just kind of how Mocha organizes its tests. So we'll say describe the to-dos reducer. And then inside here, we're going to write our first test, and it's going to test that our reducer responds appropriately to the create to-do action. This is probably the simplest example for now. So we're going to define our test with it, and again, this is just Mocha's way of organizing tests here. We'll say it adds a new to-do when create to-do action is received. So in order to test our to-dos reducer here, we need two things. We're going to need a fake current state to pass as the first argument to our reducer, and a fake action with a payload to pass as the second argument. And that's all going to look something like this. We'll say const fake to-do equals text hello is completed false, and then we'll say const fake action equals type, and we're going to hard code create to do here, and then we'll add a payload that has to do fake to do. And as I mentioned earlier, the last thing that we have to define for our initial setup is the original state that will get passed to our reducer. So we'll say const original state equals is loading false, and data will be an empty array. Remember that this is the structure of our to-dos in our Redux store now. And now that we've defined that initial setup logic, let's define a constant that has the results that we expect our to-dos reducer to return when we pass it these two arguments, our fake action and our original state. And to do that, we'll say const expected equals, and then we'll have is loading false, and data will be an array with our fake to-do in it. And now that we've defined the expected value, we're going to get the actual value that our to-dos reducer returns in this situation. We're going to say const actual equals to-dos original state and fake action. And last but not least, we're going to use chai to compare our actual and expected results like this. We say expect actual to deep equal. It's very important that we do deep equal here. Expected. And that's really it. Testing reducers should never be much more complicated than that. We create an initial state in action and check that our reducer returns the right thing given that state in action. So if we run our tests now by typing npm run test, we see that we now have a passing test in our test suite. Now let's move on to testing thunks. Admittedly, thunks can sometimes be one of the trickier things to test, but I think I've figured out a decent way to do so. Keep in mind that this is probably just one way to test thunks, and depending on your situation, there might be better ways to do it. So with that disclaimer, let's start off by creating a new file in our tests folder called thunks.test.js. And then just like with our reducer tests, we're going to say import expect from chai, and we're going to import our load to-dos thunk, which is what we'll be using for the example, from //thunks. And once we've done that, we're going to create a describe block, describe, and as I mentioned, in this video, we're going to be writing a basic test for the load to-dos thunk. So we'll say describe the load to-dos thunk. And now that we have that, we have to actually think about what it is we want to test about our load to-dos thunk. For the normal operation of our application, we basically want our load to-dos thunk to do three things. We want it to dispatch a load to-dos in progress action as soon as it starts. We want it to load the actual data from our server. And then we want it to dispatch a load to-dos success action with the to-dos it loaded from the server. So let's look at how to test each of those things. So before we actually write any tests, the first thing we're going to do here is install 3 new packages. You'll see how each is used in a moment. We're going to say npm install savedev signon, S-I-N-O-N, node-fetch, and then fetch mock. And now that we've done that, let's take a look at how to test that our load to-dos thunk dispatches a load to-dos in progress action. So if we look at our load to-dos function, we can see that when we call it, it gives us back an asynchronous function that takes dispatch as an argument, and it calls dispatch several times with the actions we're looking for. So what if we were to create a fake version of this dispatch function and pass it in ourselves, and then check if it had been called with the right arguments? Well, as some of you may have guessed, that's exactly why we installed the signon package into our project, to create a fake function that we can pass in that keeps track of what arguments it was called with. So this gives us a starting point. We're going to import signon up at the top of our file, like this. Import signon from signon. And then we're going to create a block for our tests. We'll say it dispatches the correct actions in the success scenario. And this is going to be an asynchronous function. since we're testing an asynchronous thunk. And then inside this test block, we're going to start off by saying const fake dispatch equals signon.spy. This is how we create a fake function that keeps track of which arguments it was called with. So now that we have our fake dispatch that we can pass to our thunk in order to make sure it calls it with the right actions, there's just one thing we still have to do. We have to figure out what to do with this fetch statement in our thunk. You see, for testing purposes, we definitely don't want to be sending real requests to our server, especially when we write tests for adding or deleting to-dos from the server. So we have to find a way to replace this fetch that we're using in our thunks with a fake fetch that behaves like the real fetch. Well, as you may have guessed, that's more or less why we installed the node fetch and fetch mock functions earlier. Together, they provide the exact functionality we're looking for. So here's how we use those packages. Up at the very top of our file, we have to say import node fetch, and then import fetch mock from fetch mock. And then down in our tests, we're going to go through a few steps. The first thing we have to do here is define what we want our fake fetch to return when our thunk calls it. So we'll say const fake todos equals an array with fake objects that just have text equals 1 and text equals 2. And since this is just a test and our thunk doesn't really rely on the structure of the to-dos it gets back, we don't need to worry that our fake to-dos here don't have the same properties as real to-dos. So now that we have our fake to-dos, we have to put a line right underneath it that says fetch mock.get, and then the URL that we're fetching from, http://localhost 8080/todos, and we'll pass fake to-dos to it as well. And what this does is when our thunk tries to use fetch to send a GET request to this URL, it'll just get back the fake to-dos that we defined instead of sending an actual request. And since this line here actually changes the behavior of fetch, at the bottom of our test we have to restore our fetch to its original state by calling fetchMock.reset. Okay, so we're getting really close to having a functional test here. We only have a few things left to do. First, we have to define exactly what we want the actions that our fake dispatch gets called with to look like. We'll define these as two new constants right in the middle here. So we'll say const expected first action equals type load to-dos in progress. And this is because we're expecting that the first thing that our load to-dos thunk will dispatch is the load to-dos in progress action. So then, for our expected second action, we're expecting that our load to-dos thunk will dispatch a load to-dos success action. So we'll say type load to-dos success, and then the payload for this action is going to be to-dos with the fake to-dos that we defined up above. And once we've done all that, we have to actually call our thunk like this. We'll say await load to-dos, empty parentheses, and then pass it the fake dispatch. And last but not least, here comes the actual test. We have to test that our load to-dos dispatch the actions that we expected it to in the correct order. And we do that like this. We say expect fake dispatch dot get call 0, this is referring to the first call that was made to our fake dispatch, .args 0, which is referring to the first argument that was passed during the first call to fake dispatch. And then we're going to say that we want that to deep equal our expected first action. And likewise, we'll do the same thing with the expected second action. We'll say expect fake dispatch dot get call 1, the second time fake dispatch was called, .args 0, dot to deep equal expected second action. And that's it. If we run our tests now, we'll see that our new test passes. So then, the takeaway here is that when you test thunks, you'll usually want to make sure of two things. First, you'll want to make sure that your thunk dispatches the correct actions at the right times, and second, you'll want to make sure that it makes the correct external requests. In our case, we were assured of this because the second action our thunk dispatched contained the fake results that we made our fake fetch return during the test. And now we move on to testing selectors. I'm happy to announce that in general, selectors are one of the easiest parts of the React ecosystem to test. Just like testing reducers only required us to define an initial state and an action, testing selectors generally only requires us to define the relevant parts of the state. So testing the base selectors that simply pull something out of the state as is a bit of a no-brainer. I'm not going to spend any time demonstrating it. However, if we move on to our slightly more complicated selectors, there are a few tricks to testing them. As an example, let's see how to test our getCompletedToDos selector. Now, the first and most obvious way to test our getCompletedToDos selector would be to simply recreate the whole state and pass it to our getCompletedToDos to test that it returns the right data. And in our case, this would work fine since our state is so small and we haven't yet built up a big library of selectors that use the results of other selectors. However, in practice, especially as our app gets bigger, as I've said, the only thing we really need to test is the last function that we pass to create selector. So for example, we would have already tested this getToDos selector, so we'd be recreating the entire state just to test that this last function we've defined here works correctly. And that's not really necessary. So this is where the Reselect library provides us with a nice solution. The selectors that we create using the createSelector function have a property called ResultThunk. So if we say getCompletedToDos.ResultThunk, and what this is here is just a reference to the last function that we passed to createSelector. And we can use this in our tests to simply pass in whatever previous selector results our selector requires. So we could define some fake to-dos and simply pass them in here instead of having to recreate the whole state. So that might sound a little complicated. Let me show you what I mean. Let's start off by creating a file to hold our selector tests. We'll call it selectors.test.js. And inside here, we'll start off by importing expect from chai, and then we'll import our getCompletedToDos selector. Import getCompletedToDos from ... selectors. And then we'll set up our test the same way that we've done with our other ecosystem pieces. We'll say describe the getCompletedToDos selector. And we'll say it returns only completed to-dos. And here's where the actual testing logic comes in. What we can do is simply define the to-dos list that would be returned by getToDos in our selector, right here. So we'll say const fake to-dos equals array, and we'll just define some fake to-dos. Say text, say hello, is completed true, text, say goodbye, is completed false, and text, climb Mount Everest, is completed definitely false. And then we define the results that we expect our selector to return when the to-dos array in our state is the one that we just defined. So we'll say const expected equals an array with only this completed to-do in it. And then to get the actual results, we say const actual. And here's where we're going to use the result thunk property of our selector that I mentioned earlier. We'll say get completed to-dos dot result thunk called with fake to-dos. And then we simply have to check that our actual was deep equal to our expected. And that's it. All we have to do when testing Reselect selectors, that is, provided we're good coding citizens and test all of our selectors, even these ones up here, is define what data should be returned by the smaller selectors that our current selector relies on, and then use the result thunk to pass that data as arguments into the final function we pass to our selector. And if we run our tests now with npm run test, we should see that all of our tests pass. Last but not least, we're going to move on to the subject of testing styled components. Now, the method for this one is generally pretty simple. We don't exactly test our full styled components. The only thing that we can really test in our styled components is the logic we put inside them. For example, when we use the created at property on a to-do item to decide whether or not to display a red border at the bottom in the list. So what we should do in this case, in order to be able to test this logic efficiently, is pull this logic out into its own function. So what we're going to do is say export const get border style for date, or something like that, equals, and we're going to say starting date and current date. And this is going to be a slightly modified version of what we did down here. So we're going to say starting date is greater than new date, current date, minus 8,640,000, which again is the number of milliseconds in a day, times 5. And if this condition is true, we're going to say none. And if it's false, we're going to return the solid red border. 2 pixels solid red. And now what we're going to do, and instead of having all that logic inside this styled component here, we're going to say props get border style for date. And for our current date, we're going to say new date props dot created at. And for the starting date, we're going to say date dot now. And again, the reason we would go to the trouble of doing something like this, well, first of all, it makes our styled components more readable, in my opinion, but it also allows us to test this logic that we have in here. So let's create a new test, and we're going to call it todoListItem.test.js. If we were to create a separate file for our styled components, this would be something like styled.test.js. And this is going to be pretty much the same setup as with our other tests. We'll say import expect from chai, and then we'll import our get border style for date from /todoListItem. And we're going to set up our tests just like we've done in the other videos. We'll say describe get border style for date. And then we're going to say it returns none when the date is less than 5 days ago. And we'll have another test that says it returns a border when the date is more than 5 days ago. And now that we have that, the actual testing is going to be really easy. All we have to say is const today equals date.now, const recent date equals new date, date.now, and we'll make it for 3 days ago this time. So 86,400,000 times 3. And then we'll say const expected equals none and const actual equals get border style for date, recent date, and today. And then we just have to check if our expected and actual values match. So we'll say expect actual to equal expected. And if we run that first test now, we'll see that that passes just fine. And writing the second test is going to be pretty similar to the first test. The only difference is that instead of having it be just 3 days ago, we're going to have it be 7 days ago. And our expected value in this case is going to be 2pix solid red. You may or may not want to get that specific in your tests. So if we run our tests again now, we see that that passes as well. So that's pretty much the basics for testing styled components. In other words, you don't actually test the styled components themselves, you merely pull out the logic that's contained inside them and test that on its own. Well, we've covered quite a few topics in this course. We started off by creating a basic React application from scratch, and then used this as a jumping off point to learn about the many different ecosystem tools that are available to us, including Redux, Thunk, Reselect, and styled components. We learned the basics of each of these technologies, such as how it works and why it's useful, and then we walked through the process of adding each of them and integrating them into our React project. And last but not least, we saw how to test all the ecosystem pieces that we covered in this course. So now that you've gotten a solid introduction to the React ecosystem, you might be wondering where to go next. Well, there are several things I'd recommend here. First and foremost, I'd recommend that you start trying to use the ecosystem tools in your own applications. You'll be amazed at how quickly you'll get the hang of this and how much the quality and ease of maintenance of your React projects improves once you do this.